Good morning, everyone. Thank you to be here also for the second day of the third water reuse day of the project FIT4REUSE. Yesterday, we had the opening session and we started discussing about the first pillar of the project FIT4REUSE. Yesterday, we discussed that we have seen the pilot systems and the results related to the innovation pillar, where treatment solutions have been developed and tested. Today, we will start with the pillar number 2 and pillar number 3. We will see these sessions in the morning today, and then after the lunch break in the afternoon, we will have a round table and a discussion panel, and also a speech from our project officer, Marco Orlando. So also today is a very dense program. We have a very dense program, thanks to the speakers that are here. And the session that is starting on the pillar number 2 will be moderated by Stevo Lavnic from University of Bologna. Please, Stevo, be on the stage and enjoy the day.
Thank you, Tilio. Thank you for introduction. It's very nice to be here. Finally, after 2 years, collaborating with all of you online. It's very nice to see you in person. So basically, yesterday, what we saw are the technologies we developed as the project to treat non-conventional water resources. Today, at this session, we will talk about the use of non-conventional water resources. So the water that we produced, how we can really use it in agriculture to improve available water. We will follow the same format as yesterday, more or less. So we will have the keynote speech. Afterwards, we will do the stakeholder message, survey, and then the presentations. And in the end, you will have time to ask questions. So as I said, this session will be on the use of non-conventional water resources and the real possibilities for it in agriculture. And it's my great pleasure, and I cannot think of a better person to introduce the topic than Adriano Battilani, who has a really wide experience in agriculture water management. He's the General Secretary of the Irrigation Europe, and he will tell us about the different steps that we can follow for efficient and sustainable use of water resources in agriculture. So thank you, Adriano. Thank you for being here.
Okay. This is the presentation, so we will talk about the steps that we see as irrigation association that must be taken to have an efficient and sustainable use of the reclaimed water in agriculture. What happens? I was holding in the opposite side, sorry. So the first point is that the new European regulation has completely changed the scene. Now we cannot anymore talk about water use thinking about a single sector. We have to refer absolutely to a complex system that is the so-named water use schema, as is mentioned in the law itself. This kind of schema has a characteristics. The main characteristic is that it can be split in 3 parts, main parts. The one is following each sector. The first sector is the water agency, and we have first to decide if it is interesting to reuse water or if it is better to keep the water inside the urban area and to make a recycle instead of a real reuse. The second sector, in many cases, is managed by agricultural water managers that have a different approach and a different responsibility that is mainly on the distribution and storage of the water, transport, distribution and storage of the water. And the last one is the productive sector, are the farmer itself that have to take care of the impact of this water on the soil, on the production, on their own business. We have also 3 different environments. The first is an urban environment, a peri-urban environment in some cases. The second one is the agro-ecosystems, so with different approach and different kind of technology and solution that can be applied. And the last one is the purely productive one, so it's business. We have to manage in these three ways inside the simple, let's say, management of a single water use, reuse schema, all these conflicts. Because unfortunately, what we learned in the last year in many countries of Europe, the management of water during drought is generating conflict intersectorial. So, the first step that we can suggest, that we can say we need to approach an effective water use is to define the targets, but define the targets means that we have also to avoid excess of caution. Because what we are observing is that the excess of caution is now a kind of leitmotif that we are finding in all the discussion at the national level. They are stepping back as much as they can toward the safe idea to have some threshold, to have some safe and comfort area in which bureaucracy can manage the water use without taking any kind of direct or indirect responsibility, which is totally different to the risk approach and fit-for-purpose criteria that has been set out for the first time in the European law and in this specific law. When we are talking about apply solution, for instance, for a problem like multi-crop irrigation system fit for purposes, in the same water use schema, we have normally more than one single crop and more than one single irrigation system that have to share the same kind of resources and produce altogether a lower level of risk that is possible. So, or, for instance, we have problems with mixed sewage systems that are generating an input of the wastewater treatment plant that is often out of control of the capability of the wastewater treatment plant itself. And now it's important to talk about technology, and this project was developing some technology that can interestingly help to solve this kind of problem. And this is impacting on the other sector that we have mentioned before. When we're talking about the solution, the bad and the sad news, but it's not really news, is that the technology itself cannot solve the problem. We are in need of a hard technology solution, soft technology solution, and then collective management and policy management. All together can define a step forward for one of the problem that we are pointing out. So, for instance, if we want to define the targets avoiding excess of caution, we have to identify countering, which means that is mapped, must be mapped correctly, the water use schema, and set all the multi-crop and irrigation system inside. Modernize infrastructure, set up infrastructure for backup, supply and emergency management. This is hard intervention that requires new technology, a new technological approach. But we have also to identify risk for any specific water use system and their tolerable level. Not just the risk and the maximum potential level, but the tolerable level, standardized risk analysis methodology, and so on. Or, in terms of collective management, we have to go toward find a strike a balance on risk management. Because risk management means that somebody has to undertake some risk. And everybody has to be aware of the level of risk is undertaking and what is the trade-off and drawbacks of this kind of risk. And so we have to agree on water quality level fitting most of purposes, avoiding the last mile effort. Considering the complexity of the schema that we have just drafted before, to have a water quality that is fitting all the purposes, I think is a bit unrealistic. Then we can improve. In which way? We can consider barriers to remove barriers. Barriers are the systems or infrastructures like natural-based solution or field treatment system, portable disinfection system, many other kind of technology, or better digitalization and interoperability, making use of water nutrient imbalance for manage better the risk solid to remove something that is detrimental for the irrigation system or for the crops. It's matter to have a different kind of filter that must be portable, must be effective, must be easy to be maintained. It must be not create dangerous wastes because the farmer cannot manage dangerous wasting, but this is the way to have something decentralized that allow to refine for the very last level of customization. And the same for portable disinfection. We cannot rely on the disinfection made at the point of compliance when the water is released to the other system. Too much time, too much distance, too much interference can cause regrowth and let's say, spoil the effect of the disinfection we did in the treatment plant. So it's probably necessary to have some option to make portable disinfection system and to use this portable disinfection system at the field level to be sure that the water we are using has no impact on the food chain. There is many other aspects we can discuss, but another one that I think is very interesting, but is more on the agricultural side, is coupling soil husbandry with irrigation technology and strategy. Going toward precision irrigation, going toward regenerative agriculture, going toward agriculture 4.0, we are implementing possibility and technology that make more and more precise the way we are delivering and using the water, which means from one side avoid the contact with the edible part, reduce the inherent risk for residual contaminant and pathogen, but on the other side we are concentrating more and more the water in a small area and in strict contact with the root zone, which means that the contamination path that can enter through the roots via xylema inside the plant are magnified by the strict contact and pressure. So both the aspect has to be managed in order to reduce the risk. One of the main aspects that we know is facilitating the use or reuse of water is to have an increase of organic matter rich in carbon, because this kind of organic matter is making, for instance, heavy metal, organic heavy metal, that are normally not uptake easily by the roots. So we can interfere to this process with a different crop husbandry and with different irrigation system and irrigation strategies. But what is needed mainly, not the technology. In that case, we have a lot of technology already on shelf and more that are that will be soon on shelf as well. What we need now is farmer reskilling, because the farmers are not ready to think the use of such technology also for this particular aspect. We have to financing the farm equipment's upgrading, because in many cases is a matter to change technology that has been changed less than 15 or 20 years ago. That is the normal mortgage time for an equipment in agriculture, and make organic matter of certified quality, accessible and affordable. 3 points: certified quality, accessible and affordable, which means that the organic matter that is normally produced in many cases has no quality certificate or not even quality characteristics that are known. So we are taking the risk to bring contaminants that we are removing from the water through the organic matter, different path but same impact. We have the problem of accessibility. Organic matter is produced now not by the few cattle that every farmer has in his home, but is produced in a specific location, so it must be transported. And to be transported organic matter is not easy and is mainly costly for unit and for unit of fertilization capability and affordable. The cost must be affordable for the farmers and it must be comparable with the chemical nutrition that we are normally used to approach. Economic self-sustainability is one of the key points. I will not spend too much word on this because I think that everybody can realize that if the system is not able to pay back itself, it cannot be applied because nobody will support it in the long run, and then when we come to the productive sector, it cannot charge itself of services to the society without any benefit because commodities will not pay back this kind of approach. We were discussing about the conflict that can be generated mainly by clash in the socio-economic management, and to have monitoring system and certifying governance. Monitoring system means that every step must be well monitored as possible in real time in order to overcome the lack of trust and confidence of the consumer. We have to produce evidence that there is no risk, and certification is a step that we are taking as association. We are producing a certification of irrigation sustainability, which means that all the resources are used in a sustainable way in order not to add resources to a system that is wasting, not to add risk to the food chain. But in spite of everything, still the water managers are constantly endeavored to justify their action because if you ask all the citizens, everybody is in favor, but when they have to take action, everything is confused, is unclear, there is problem, there is doubt. So one of the main steps, and I think the only way to put together the three aspects, hard technology, soft technology, and collective management, is nudging environmental behavior, which means to maintain a positive self-image, stimulate people to do action that are making them in line with their conviction and their style of life, conform to their social group. So they must be recognized themselves. Keeping things the way they are when changing means to offer water use not as an option, but as the standard, and then an opt-out option. So if you say nothing is water use, if you don't want it, you have to flag the opt-out option and help with guidelines, example, whatever else that is making simple. This is nothing new. This is the 4 elements of the marketing and the environmental behavior management that are normally used in socioeconomic management. Thank you.
Thank you, Adriano. It was a very interesting presentation, I think, because it showed us about this clash that we have between policy-based approach that we'll be discussing in the afternoon in the third pillar, and the approach based more on risk management, something that is coming into force now, that we will hear today about in this pillar. So thank you very much, Adriano. In FIT4REUSE, we care a lot about our stakeholders. So we are in constant communication with stakeholders for the last 3 years. We developed different systems to stay in touch with them, to share the knowledge. And so now we will see the video message from one of our stakeholders, Mr. Kais Usleti from Tunisia. He's a member of an important agricultural association in Tunisia, and he will tell us about the problems that the farmers in North Africa face when it comes to available water and the water available for agriculture production. So let's see the message.
قيس الوسلاتي فلاح ومربي وعضو في عديد جمعيات اللي هي بالمجال الفلاحي. اليوم بالتغيرات المناخية اللي نعيشوا فيها في الوقت بتاعنا الحقيقة من عام قاعدين نحسوا قاعدة الموارد المائية قاعدة تنقص بصفة ملحوظة. عندنا حاجة كبيرة برشا باش الموارد الأخرى كيف تحريك مياه البحار، كيف معالجة استعمال المياه المعقمة. التغيرات المناخية هذه جابت لنا أن نقص في الأمطار، ونقص في الأمطار هذيا باش ينقص لنا في الموارد في الطبقات المائية اللي نحن قاعدين ناخذ منها في الماء، سواء في العميقة وإلا في السطحية. ولذا ما ثماش حاجة وقاعدين نلاحظوا اللي المياه الجوفية قاعدة تملاح وقاعدة تنقص برشا. ولذا طريقة من طرق أنه نلقاو موارد باش نسقيو بها الأعلاف ولا بقية النباتات متاعنا هي هالموارد اللي نجموا ناخذوها بطرق خاطر تستعمل طرق معناها طبيعية تولي في الكلفة أقل. وزيد بخلاف هذايا هو أنه معناها في الجفاف اللي قاعدين نعيشوا فيه ما عندناش مصادر كبيرة برشا باش نجموا نستغلوها في استعمالها في الزراعات نتاعنا. أنا مع استعمال المياه المعالجة. علاش؟ لأنه معناها خاصة احنا كمربين معناها نجموا نستعملوهم في تكثيف واستعمالها في الزراعات العلفية. الزراعات العلفية تحتاج خاصة نستعملوها في الصيف كيف الميس وكيف الفصل. تستعمل كمية كبيرة من الماء، ولذا هو حل من الحلول أنه نستعملوا هالمياه المعالجة باش نكثفوا بها الزراعات هذه. أنا كفلاح ومربي نشجع البحث العلمي باش يطور هالمناهج والطرق باش في معالجة هالمياه هذه. والبروجي كيف FIT4REUSE هو بروجي يستعمل في حاجات بروسيدي ناتوريل، حاجات من الطبيعة باش يحسنوا في معالجة المياه المستحضرة.
So that was Mr. Kais Usleti from Tunisia. We heard about the problems that agricultural producers face there. It was a very nice introduction also for this session because we heard about the saline water intrusion into groundwater having, let's say, different quality, and it's a problem actually that we can try to mitigate through aquifer water recharge that you will hear in some minutes about. So the next in the program is our survey. We did our one survey yesterday. Tadej was really easy on you yesterday. They were easy questions. I'll try to be more strict. So we will check your knowledge on this topic. So here we have QR code. You can also go to slido.com and insert this code here. Let's wait a bit more. I see some people are still connecting. And I also invite our participants online to do the same. So you can zoom the code in, the QR code, scan it, or go to slido.com and introduce the code, the number code. Okay. So, what percentage of fresh water withdrawal, the first question, is on average used for agriculture purposes? So, in other words, of the total water we withdraw in a year, Do we use for agriculture 20, 40, 70, or 90%? So let's see how much you know. If I can give you a hint, I would say 20%, for example. So we have 30 answers so far. I'm glad that 32. I'm glad that the people find this interesting, also online. Okay, I think we can close the voting now. So most of you voted for 70%. Not many people took my hint, so you couldn't be fooled. So yes, you were right. The correct answer is 70%. According to FAO data, agriculture is the biggest water consumer globally, and it is responsible for about 70% of fresh water withdrawal every year. In the Mediterranean region, but that we focus on as a project, it's even higher due to climate change and bigger water scarcity issues. So let's go to the second question now. So this is the EU-based question. So how much of treated urban wastewater is actually being reused in a year in the European Union? So we have four answers offered: 0.1%, 2.5%, 10%, or 20%. My hint would be 20%. So we had 28 answers so far, 32. Seeing this number increase, it reminds me of the, who offers more. Okay, we have bigger participation in this question. I think we can stop the voting now. And these are the answers. So 54% of people voted for 22.5%. Again, my hint wasn't so successful. But basically, yes, the majority of people was right. In the EU, we reuse actually 2.5% of treated urban wastewater on an annual basis. And it represents actually less than 0.5% of annual freshwater withdrawals in the EU. These are the data from European Commission. And we, as the project, as FIT4REUSE, we hope to help to increase the percentage, not only in the EU, but in the whole Mediterranean region. Okay, so now that we had this little warm-up, we go on with our program. Let's dive in the actual use of non-conventional water resources in agriculture. So we will have 4 presentations today from our partners. The first presentation will be from Ecorot, Mr. Roy El-Kayem, who unfortunately couldn't be here with us today due to some last-minute issues, but we have his presentation, and he will tell us about the aquifer recharge and soil aquifer treatment. So the problem that the practice that we can use to decrease the problem with groundwater salinity. So let's see the presentation.
Everybody, I would like to apologize that I could not make it to meet you all in person. I truly hope we'll get a chance to meet you in future collaboration. I'm going to present our research regarding the improvement of SAT operation that might lead to an increase in SAT capacity. We did this research based on 5 years database in 3 recharge basins. Our story starts with the Shafdan wastewater treatment plant, located in the center of Israel. It gives service to about 2.5 million people and produces about 140 cubic meters of secondary effluent every year. The effluent flows into an operational reservoir and then toward a SAT system. It is distributed between 70 infiltration basins with a total area of 1.1 square kilometers. The treated effluent is extracted from the aquifer by 150 production wells positioned around the infiltration basin. The shaft and effluent volume is expected to exceed the capacity of the current SAT system, maybe by 2030. One of the solutions is a new facility for the excess effluent that it is now being designed and even built, I think, but might not be ready by 2030. Meanwhile, we are hoping to increase the capacity of the current SAT system by operation improvement and serve as an interim solution until the facility is built. Let us look at one flooding event in one recharge basin, drawing the effluent level over time. Flooding begins, and the effluent level is rising until the desired level. Then, keeping the level steady if we want to extend the flooding event. Then flooding stops and the effluent level drops, and the basin is drained until it is dry. After the drying period, a new cycle begins. Infiltration rate is based on many parameters, such as soil characteristics, saturation condition, temperature, solid accumulation, and more. Some of the parameters are changing even during the flooding event itself, affecting each other, what makes the effluent level drop nonlinear and harder to predict. We always say that if you want an operational model to work, you should keep it simple. So naturally, we started with simplifying the most complex element of the model, the infiltration rate. Looking at the data in the frame of the previous operation, focusing on the level drop taught us that during drainage, the effluent level drop is very close to linear. And when we went deeper, we saw that this measured infiltration rate reflects the infiltration rate through the entire flooding event. Proving this assumption allows us to design a model where we don't have to look through all the processes that results from the interaction between the effluent and the soil during flooding event, and that affect the infiltration rate. In fact, we say that each flooding event has a typical infiltration rate value determined by the previous operation and environmental condition. The methodology includes proving the linear level drop. This is just one example. We did an investigation over all 72 recharge basins in the Shaftan. I'm convinced that the unique nature of the Shaftan operation led to this result. It will be very interesting to investigate the nature of infiltration rate in different SAT systems around the world. Collecting the data, we say 5 years data, and designing features to allow us to predict what the infiltration rate is about to be in the next flooding event based on history. We chose 3 recharge basins. We aggregate the operational data and the environmental data for each flooding event. So if we take temperature, for example, we designed 3 different features based on temperature. The average temperature during the entire flooding event, the average temperature during just the wetting time in the flooding event, and the average temperature during just the drying time of the flooding event. We chose represented time of 14 days before each flooding event and set a feature to be the previous condition of the flooding event. So each feature was the average or sum of the previous condition, meaning 14 days, which is equivalent to 2 to 4 flooding events. So, for example, the average temperature dry feature is the average temperature measured 14 days before each flooding event, but only when the basin was dry. Total precipitation feature was the total precipitation measured near the basin 14 days before each flooding event. So we designed feature. The next step was to screen for machine learning models and choose the model that best predict the infiltration rate. We chose two key operational parameters: the cycle time, which is the period between two consecutive flooding events; the alpha, which is the wetting friction of the flooding cycle. For each flooding event, these parameters along with the predicted infiltration rate value allow us to conclude the state variable for the next flooding event. For example, how long should the flooding take? How long should the drainage must take? How long it should be dried? We describe mathematically the course of the effluent level over time. So for each scenario, the level was calculated dynamically using the inflow to the basin, the desired flooding level, and the predicted infiltration rate value. We simulate different scenarios and test their performances. This work was based on a 5-year database, environmental and operational. We conclude an optimal operation plan for the recharge basin that led to maximum infiltration, simulating and comparing to the 5-year measured history. 27 features were designed based on environmental and operational data. The features include operational features such as what was the average drying time 2 weeks before the current site system, what was the average flow, or when was the last tillage before the current cycle. The features also included environmental parameters such as what was the average temperature 2 weeks before the current site system, what the average radiation, or the total amount of precipitation. We also tested mixed operational and environmental parameters, such as what was the total radiation for 1 cubic meter of infiltrated effluent, and many more. Eventually, 10 features were selected based on statistical analysis, conventional linear models, and domain expert knowledge. We prepared the data, normalized it, and divided it into a training set and test set. We tried different models, including linear regression, neural network, decision trees, and random forest. The best prediction was achieved by random forest regressor using 10 selected features. The model, as you can see in red, catches most of the peaks with a score higher than 0.8, implying that infiltration rate model can successfully predict the infiltration rate of the next flooding event. By changing the key operational parameter, we designed different operation scenarios. So different cycle time or alpha leads to different operation regime. 56 different operation regime scenarios were produced using the different cycle time alpha combination. The simulation produces the course of the effluent level in the basin over time, the basin total capacity, and the graphical view of the calculated infiltration rate for each flooding event. Simulating the different scenarios proved that the ratio between wetting and drying time is the most significant operation parameter. The theoretical simulation showed improvement of 45% in the capacity compared to the measured history. So, we showed a methodology that includes simplifying the infiltration rate parameter into a single value that reflects the entire flooding event. We showed successful prediction of SAT infiltration rate by random forest regressor. We show that the ratio between the wetting and drying is the most significant parameter for SAT operation, and that alpha equal to 0.5 led to maximum infiltration. This theoretical simulation showed an improvement of 45% in the capacity compared to the measured value, but it's only theoretical, and we did it only for 3 basins without the scheduling of the entire system. What is next? To publish what we found. Unfortunately, the report we wrote is too long and not specific enough, in my opinion. It will be better to separate this work into 3 papers: proving the linear infiltration rate, the prediction model, and the simulation. Each paper will not describe only 3 recharge basins, but 72 different basins. I think it will increase the credibility of our work. In this research, we developed the methodology to find the infiltration rate model for each basin, and we also developed a simple simulation for the effluent capacity for a single basin for each flooding event, and we can run it even 1 or 5 years forward. Next, we need a good prediction of secondary effluent that feeds the recharge basins. We need to understand the treated water quality constraint, especially reduction of manganese and iron. And last and most challenging is scheduling the entire 72 recharge basins and set real-time optimization that will lead to maximum infiltration. Thank you for listening. If you have any questions, thoughts, if you think this subject is worth collaborating, please let me know. You can email me or find me on LinkedIn, and join the rest of the conference. Bye-bye. Thank you very much.
So that was Mr. Roy Al-Qaim from Mekrot, Israel National Water Company. Now we are back here in Pepole Palace in Bologna, and we will go on with our presentations. So we heard about aquifer recharge. Now we will hear about the use of non-commercial water resources for irrigation. Mr. Rémi Leclerc, who is the project manager of Ecofilet, one of the project partners. Rémi, the floor is yours.
Okay, thank you, Stevo. Good morning, everybody. Okay, so not the right side. Okay, so we continue with the uses of reclaimed water, and now we focus on irrigation. So in the frame of FIT4REUSE, we had built a network of irrigation demonstration pilots in Tunisia, in France, and in Italy. The main objective of this network was to start a guideline for irrigation designed in practice for practitioners, for farmers. For this, in those pilots, we studied the application of reclaimed water, different types of reclaimed water in agriculture, and we tried to follow different risks, to monitor different risks, the agronomic risk, the environmental risk, technological risk, focusing on drippers, mainly drippers clogging, but also the sanitary risk. So at the beginning, to build a common framework protocol between all our pilot sites, we decided to focus on 5 major impacts for irrigations. We started to separate those impacts. The first one was on irrigation drippers clogging. You know that using reclaimed water, which is always or often more concentrated in suspended matter or with nitrogen, with phosphorus, with pathogens, you got more clogging, resulting in more cost for farmers because more renewal needs. And another impact we focused was on sanitary hazards with pathogens, with micropollutants, then salinity and sodicity hazards, fertilizers properties, and water quality in storage. How does the water evolve during storage under different conditions, depth, temperature, length of storage, duration of storage. And of course, we've also we changed the protocol during the period to add COVID monitoring and micropollutants as well. So the network of irrigation pilots we built was based, as I said, in France, in Montpellier, in Saint-Jean-de-Corny. Another one in Tunis at Isbat University, and another one split in 2 in Italy with some tests in Bologna and some tests in Cesena, wastewater treatment plant. And we also have the opportunity to get feedbacks to supply our future guideline on irrigation using data from different partner pilot platform from Malaga, from the project Wishwater, and also another pilots focusing on salinity in France, in Montpellier as well. So just a few pictures of one site in the pilot demonstration site in Italy, in Cesena wastewater treatment plant, where in lithymetric cases, individual lithymetric cases, we could test two types of reclaimed water to irrigate peach tree and to irrigate tomatoes as well. And here are some pictures from the site in France, the FIT4REUSE platform, where we could test 4 types of reclaimed water from different reclamation systems, and then have different conditions for storage, as you can see at the bottom left, where we could make some tests on durations of storage, depths of storage, and monitoring it according to the depths and according to the duration of storage. And we could grow also salads and tomato crops. We had the opportunity, we were supposed to make some tests for aspersion irrigation in an open field, but due to COVID situation in France, it was forbidden in 2021 and 2020. So, I forgot to talk about the Tunis pilot, focusing more on sunflowers, wind sunflowers that were grown in pots and in a greenhouse at Isbat University. So we could not monitor all the parameters, monitor all the impacts in all the sites, so we decided to split to have representative sharing of all the impacts between all the sites. And for each of those impacts, we design a baseline protocol to monitor the risk for each of those 5 impacts. If you look on the left, on the, if it works, yes, on the column on the left, we're following the chain of water from raw water, reclaimed water, irrigation water, then drainage water in soil, in crops, and in irrigation material. We can have different points of water uptakes to monitor different parameters. For example, for drippers clogging, we're monitoring the flow in the irrigation material and the suspended material, the nitrogen and the phosphorus, which are key elements to monitor clogging impacts. The main results we got for drippers clogging, I will not be able to focus on all the results we got, so I will go quickly on some of them. So on drippers clogging, what that, using some treatments like flushing plus chemical treatment, we could decrease the clogging and then reach comparable results with our witness, which is in France, which was water from the Rhone River, and thus resulting in less renewal of drippers, but higher cost for treatment, as I said, for flushing and for chemical treatment using hypochlorite acid. Then we also focus on sanitary hazards. As Adriano mentioned before, there is a huge stake in the future in the risk management downstream of after reclamation systems, considering the multi-barrier approach. So what we tried to do was to monitor some parameters, the regulation parameters from the UE, like Escherichia coli. We are only focusing on Escherichia coli in different points of the system to see how much do we decrease the level of Escherichia coli at each point of the system, at the entrance of the drippers, out of the drippers. We are supposed to do that for irrigation aspersion, but we could not, unfortunately. And also into the crops, before the crops, in the drainage water, to have a huge map of what we could have in terms of pathogens at different points of the system. Then we also focus on sanitary salinity hazards. As you know, using reclaimed water, we are dealing with salinity issues. Where does salinity comes in reclaimed water? From salt intrusion into the groundwater. It could also come from our domestic uses. And in France, we were dealing in our pilots with something very, never met before, was with softeners. With softeners in small wastewater treatment plants, since all the night, all the softeners reject all the salts at the same time, we had huge peaks of salinity during the night, and it was very difficult for us to deal with it after the treatments, because we had huge impact of around 10 decisiemens per meter at the end when when reusing the water. Salinity hazards can have impact on yields, you know that, but more on soil as well. And on soil, I have to say that considering proper leaching from the rain, but also additional leaching that was required, we were able to control this risk. And fertilizers property, I will go on with it just after. And about water quality storage, as I said, it's more, it's like maybe like a gap in the UE regulation, in that we have to reach good quality after the reclamation systems, but what is going on for during storage? What is going on with all the parameters that we have to monitor, and under which condition does that evolve? And this is something that we have monitored as well under different conditions. So if I focus now on some fertilizer savings, here are some results for Italy and for France, where you can see some theoretical results for nutrients economy. They can go from, as you can see, from 0.4 to 98%. These are theoretical results, because you have to understand that fertilizer savings depends on the quantity of water you bring, the quality of the water, and the compositions. Is it more nitrogen, mineral nitrogen, or organic nitrogen? And also from the crop requirement, and also from the type of soil. The conclusions we have had is that considering regular irrigation with reclaimed water, we could see that actually there was an accumulation of fertilizers in soil, of available, let's say, nitrogen, which will be available for crops during all the years of irrigation during the 3 years. This accumulations was 2 times higher with using reclaimed water than conventional wastewater. And just to finish that, we also share all those comparison data in the guidelines, so you could meet them, you can read them into the guidelines that are coming with all the other pilots, partner pilot sites that I mentioned before, the one in the water, which is there. And I thank you all for your attention.
Thank you, Remy. So we heard about the real application of non-conventional water resources in agriculture in different parts of Europe, of Mediterranean region. Now, our next speaker will be Mr. Rafael Casillas, who is BSU project manager, and he will tell us about the guidelines that we as a project developed using all these results obtained in the field. So, Rafael, thank you.
Thank you very much, Esteban. Okay, I will talk now about one of the results of FIT4REUSE, which are the irrigation guidelines for practitioners. I think I have to. Oh, this is not my presentation. Yeah. Oh, okay. I think I'm just now I have it. Good. Which is deliverable 6.3 of FIT4REUSE. And well, the purpose of these guidelines is to complement other results from FIT4REUSE. We have seen risk impact, but also there are impacts, for example, in crop productivity. Also is important the issue of the nutrients, which is another benefit of using reclaimed water, and usually is not considered in the proper way. So we need proper management practices in order to minimize the risks and the negative impacts and maximize the potential benefits. These guidelines are intended to be an advisory document, so they are very practical and extract the knowledge from the project and from other literature resources. The contents of the guidelines are shown in this slide. We provide a summary of the regulation, of the European Regulation 2027/41, which sets the standards for European countries, and also it's a reference document from non-EU Mediterranean countries, so it's important to have this information. We summarize different technologies for water reclamation and disinfection. We comment on different irrigation methods and what are the implications with regards to the use for irrigating with reclaimed water. We also have a section on crop nutrition and mass balance to support farmers to at the adequate dosage of fertilizers. We comment on the effects of salinity, the storage and distribution, and finally, soil aquifer recharge. I will just comment briefly some of the information which is included here. Some of them, it's really a repetition of topics that have been discussed previously. For example, the European regulation set the standards according to this fit-for-purpose principle. So it makes difference between different quality classes from A to D, and these quality classes depend on the type of irrigation method, on the contact between reclaimed water and the crop, and finally on the use of this crop, depending if it's consumed raw or for processed food or other applications like industrial or ornamental applications. So they go from more stringent, which is the quality A, to less stringent, the quality D. According to this, they have set quality standards, and it's worth to mention that some of the standards are really difficult and to achieve. Like for quality A, we have 10 UVC per 100 milliliter, which is very, very tough and requires very effective treatment. So according to this, we have to say that conventional treatment in municipal wastewater treatment plants do not meet these requirements. We need an additional treatment and an upgrade of the treatment infrastructure in order to ensure that the reclaimed water, the treated water, pose no risk to the environment, to human and animal health. So we need to ensure there is an appropriate treatment. That's the first stage. So we summarize different treatment processes in the guidelines according to this fit-for-purpose principle, and depending on the quality class we want to irrigate, we can use different treatments which are summarized here. I will maybe comment a few of them. For example, membrane filtration is usually very effective to removing pathogens, but also we have high investment and operational cost, and also there is high level filtration but not disinfecting in the long-term distribution and storage, so additional disinfection usually is needed. Constructed wetlands are probably very convenient because of the low operational and maintenance, also lower investment costs. However, achieve high quality like class A, it might be difficult, and maybe it needs combination with other treatments. And well, I will not extend more on this. You have the information in the guidelines. We also comment on different disinfection alternatives, and I would like just to focus on chlorination and ozonation because of some specific concerns. For chlorination, it's probably the most used disinfection method because it's effective and it's cheap and simple to apply, but there is a concern with the disinfection by products, which was also commented yesterday. For example, the trialomethanes and alloacetic acids, which may have a negative impact on the crop. So some authors recommend a limitation in the use of chlorine of a maximum of 1 milligram per liter. However, this is not really homogeneous in literature, and even also the same authors say that this has to be case-by-case studied because there are some crops which are more sensitive to chlorine. From ozonation, it's also very effective and has some advantages. For example, the contact tanks require less time of ozonation, and this is an advantage against chlorination. Also, oxygen is provided. This is good for irrigation because it's positive for the roots. It destroys and removes algae, which is one of the concerns farmers have when using reclaimed water, because algae grows in a context of water with high nutritional value. So ozonation helps to reduce this algae. DBPs can be formed as well, but it's true that there is less concern on the effect in agricultural irrigation than the effects that may have in water supply. And ozone has an active life of approximately 25 minutes on average. This is lower than the chlorination, and this is also a disadvantage. Ozone cannot be transported, so it must be applied at the point of use. And the capital cost are higher than chlorination. So there are advantages and disadvantages. And this is commented in the guidelines with other disinfection methods. We also comment on the different irrigation methods and the advantages and disadvantages when using reclaimed water. For example, we have gravity-driven and surface irrigation methods, including flat irrigation, furrow irrigation. These are having a closer contact between the crop and the reclaimed water, so more concerns has to be considered with regards to protection of workers and also the potential risk of contamination of crops. Pressure-driven irrigation, we can differ between sprinkling irrigation and drip irrigation. For sprinkling irrigation, there is the risk of aerosolization, and then therefore it has to be met some minimum distance between application and potential contamination of the environment, on houses surrounding. And for drip irrigation, it's probably the most effective method, but there are the concerns of clogging. We have here inline drippers and online drippers. Inline drippers have the dripper in the lateral side and online on the top. And inline drippers are more effective in terms of avoiding clogging. So here we have a table in the guidelines with a comparison between the different methods. Crop nutrition, it's very important because farmers need to benefit from the presence of nutrients. In the reclaimed water, we have a composition which is very similar to the common fertilizers composition, but we need to do a proper nutrient balance. This means that we have to take into account the nutrients inside, and in the guidelines, we have a practical example of calculation. It's important in this calculation to analyze the reclaimed water because nutrients vary, also to have the nutrients in the same units that we have in the commercial fertilizers, because it's, when we do chemical analysis in different units, and also we need an iterative calculation, because when we are having commercial fertilizers in the same fertilizer, there are different kind of nutrients. So this calculation is complicated, and we provide an example in the guidelines, which is shown here. Well, salinity is also another concern. I go fast because we ran out of time. It difficults the ability of the crop to get the nutrients. So also some management practices need to be taken into account, like select crops which are tolerant to water salinity, to include drainage facilities, and also scheduling irrigation. Yeah, that's it from my side. We have here some reference, and you can find the guidelines in the website. Thank you very much.
Thank you, Rafael. So we heard about the guidelines we developed. I think that the highlight topic of this morning actually was this risk-based approach. So the shift from policy-based to risk-based. And our next presentation by Professor Francesco Fatone will talk about the risk management approach that we adopted in FIT4REUSE and that we developed. So Francesco, the floor is yours. You have 3 minutes.
Thank you, Steve. This is more challenging than yesterday. I have a longer presentation, shorter time, but then I will have a better dinner paid by Attilio. So, I lost 30 seconds already. Yeah, that's the current hot issue, because the new water use management plan guidelines in the European Union is under discussion. And what about the Mediterranean basin? So let's have an outlook about the current approach in Europe and how we can adapt this to the Mediterranean basin. So in this presentation, we start from the context. Let's see in practice and in detail how we are having this approach, and let's then make the FIT4REUSE approach in the context of our technologies and solutions to get to the conclusions. So when we started working on this project, there was no discussion ongoing. So we started from the worldwide standard, national standard, the most advanced cases that are sometimes very different from Europe and from Mediterranean, so we cannot take the Israeli case and adapt this to Italy because completely different context. That's why we had to harmonize everything. That was our starting point, and well, the approach was actually upgraded and updated by recent literature. And in the approach, we have to start from risk characterization, integration, and prioritization of risks. Only then we can take into account the technologies and the performances, and it's very important to have the right communication. I like very much, thanks Adriano, this was a great presentation, because that's actually the tolerable risk is our main target, and also the last mile. That's a very important concept, because the last mile is for the farmer usually, and we cannot ask the farmer to be the main responsible of everything then. So actually our presentations are connected, I think. So this is the scheme. What was missing, I think, in your presentation was the catchment. This is sometimes is not also taken into account by the current regulation. It is starting from the treatment plant, but before the treatment plant, we have the catchment. And very often, that catchment is including industrial influent. Yes, we discussed with ATF in Tunisia. In Tunisia, we have industrial influent that sometimes is not expected. So what about the source of water? Then we have the treatment plant that can be more or less rural, irrigation infrastructure with different storages, and the last mile. That's very complex, and well, again, the catchment is a key point, the quality, the source quality. What about the key elements? Well, these are very well mapped, I think, already in the national and international guidelines that I was showing in the first slide. Well, we start from the preliminary information, the location. Water use risk management plans are site-specific. We cannot take and copy-paste here and there. It's site-specific. It's a lot of work sometimes. But methodology can be applied widely. So the regulatory framework that is local, quite often, is regional because it's site-specific. And it's very important to build the right team that is including the value chain stakeholders, including the consumers, including the citizens, that they will have to buy the food, finally. And to understand that the risk was minimized. Even when it's not zero, it's impossible to have risk zero, but it's tolerable. So this is a practical example how to collect information. With this, we can start. So you can see the categories, location, rural boundaries. This was the methodology that we proposed for Europe, but also can be applied also at the Mediterranean level, we think. It's not more different applying it in Italy or in Tunisia. So the team members, well, of course, this will depend on the local governance structure. Then we move to the catchment characteristics, to the sewer system or the non-sewer system, in case we have rural areas. The aquifer characteristics, because we have to deliver also the quantitative chemical risk assessments where the aquifer is very relevant. The description of the irrigation infrastructure, scheme, site, crops, and so on. And then we have to characterize the risk. The hazard type, the groups that are at risk, that will depend very much on the operators and on the crops that are cultivated there, the routes of exposure, and finally we can deliver the risk matrix that will combine severity and likelihood to get the risk and to understand if you have a tolerable risk. So it's quite a logic approach that regretfully is very site-specific. That's the real challenge. We have to know the site. Finally, for the risk assessment, the methodologies were well defined by the World Health Organization, and not only, and they mainly are two. Quantitative microbial risk assessment, where we have to identify these indicators, exposure methods, exposure barriers, probability of infection and illness, and finally we'll get to risk evaluation and compare this indicator with the human health target that is defined by the World Health Organization. On the other hand, for quantitative chemical risk assessment, we have to understand the risk quotient and to understand if we are in a tolerable concentration of those that is below the predicted effect concentration. So that's very well mapped. And what about the multi-barrier approach? What about our technologies? Well, here is a list from the literature, from pilot and full-scale application. And here we can find some of our solutions. We have a combination of anaerobic, wetland, UV, and the most innovative technologies like polymers and so on that are not in the list, of course. So here we can see, for example, the log reduction that is expected from our technologies. So by combining this log reduction, we can understand if finally, for example, this is an example of our integration that was presented yesterday, if by this combination, we can finally reach the log reduction that is expected to be in line with the tolerable risk. So this is an exercise that, starting from site-specific application, will reach the risk assessment. Of course, here we don't have any data about imprinting polymers, nano zero valent iron, although we know that CMOS these can be also effective in removing pathogens, but well, these are not listed and are not designed to remove pathogens. But well, this can be integrated by research, of course. What about the risk assessment then? Well, let's do some practical example depending on the stage of development. So first of all, we have to provide a reliable database of possible hazardous events. Here you have a list. So this is a checklist, and we have to check what we have, what we probably don't have, and what are the preventive measures that are in place. From the database, we move to the irrigation infrastructure manager. So in Italy, it's Consorzio di Bonifica. In Spain, can be the Association of Farmers, depending on the European organization. And here, in this case, again, we have hazardous events, for example, biofilm irrigation system and so on. You have a list of possible events and preventive measures, what we have, what we don't have, and in which scale we have these measures. When we move to the end user, even in this case, look, we have a list of hazardous events that we can have, and what are the preventive measures. So once we have all this, we can evaluate if our multi-barrier approach is optimized along the whole value chain. So this is the methodology. 2 minutes. Thank you, Stefano, for standing up. I'm going to talk about Mediterranean in 2 minutes now. What about Mediterranean area? Well, here you can see our situation. We are dealing with a lot of cities that sometimes are not connected to a main treatment plant, rural areas, and we have to consider that also still irrigation infrastructure is the biggest bulk of water consumption, and we have water scarcity and a high level of absolute poverty. This means that we have to understand the balance, that's the challenge, between sustainability and tolerable risk. Because sustainability, economic, environmental, and social sustainability in Italy can be different from this kind of sustainability in other countries. That's the challenge. That's the real challenge, this matchmaking. And well, if we understand this locally, we can then adapt our approach. This is what the challenge that we had in our research in FIT4REUSE. And as you can see, we were working in particular, taking into account all these guidelines, that methodology, considering our technologies. Many of them are already analyzed in terms of log reduction, for example. This is our integration. And if we consider the multi-barrier approach that is given by the combination of our technologies, you can see how we can finally get to the risk assessment that is expected. What about the grid for data collection? Even in this case, we were considering the, let's say, the conventional requirement and also the additional requirement. For example, the emerging contaminants, heavy metals, pesticides, that is, again, site-specific. And this is a challenge because we have to evaluate also the accumulation in soil. And, well, in research projects it's not possible, but that's a real challenge because soil are different case by case and crop by crop, agricultural practice by agricultural practice. And as you can see, well, we did this exercise also with consent to FIT4REUSE. Literature is very solid in this specific sector. And even in this case, you can see some examples that are fully reported in our deliverable, the list of preventive measures, and finally, as example, you can see, depending on the phase, in the monitoring phase, you can see how we have validated our treatment train, and finally, we got the validation that is even more reliable when we are different and better combination. For example, if we change from single stage constructive wetland to hybrid stage and adding the membrane system to the anaerobic reactor, we will get to a better evaluation of the risk. So as you can see, the treatment train is reliable enough to get a tolerable risk. What about the monitoring phase? That's a challenge, because then we have to provide a routine monitoring table that has to be sustainable. We cannot analyze all around the irrigation infrastructure all the contaminants. So this was done on the basis of the standard method and also on the basis of the expected effects. And finally, what about the verification? This is the last slide. We have to verify the compliance with regulatory requirement. And about what? About the human health, so mainly about pathogens, about risk to the environment. Well, this we will present it by the previous presentations, so salinity, metals, nutrients, but also contaminants of energy concern. And finally, we have to consider also the calibration activities of sensors, meters, preventive maintenance and activities, and operational monitoring activities. This plan is not static, it's dynamic, has to be revised periodically. And finally, we need to consider the emergency plan, because climate change is affecting our plants. Now, I'm from Marche region, and we had this huge flooding that was led us to the revision of the extreme theory. This was an extreme, it was not considered in the design. So this emergency plan maybe has to be in line with the climate change. That's another challenge. How climate change is going to affect, to influence our risk management approach. Thank you.
Thank you, Francesco. I think this was a nice wrap-up of our session of this morning. We don't have a lot of time left, but maybe one or two short questions if someone wants to ask. Francesco wants to ask, okay.
Yeah, I think I would stand up. Well, my question is for Remy. Where is Remy? Yeah, he's there. Very nice final results, especially in terms of fertilizer saving. I'm wondering about, well, this is actually a connection between Remy and Rafa. How this is valorized from the market. This saving of fertilizer is somehow considered, because when we think about fertigation, the point is always, okay, we are going to impact on the nitrate directive. What about what you showed? I don't have the microphone, I will use this. What you showed was very relevant. So my point is the market considering this potential saving and possible incentive policies and so on? I think you should come here. Yeah.
Yes, thank you, Francesco. So the question was, how is it valorized on the market, the fact that we save fertilizers? From my point of view, as an engineer working on water reuse in different projects, I can say that often in practice we make recommendations. We say, in your case, when you will build water reuse with this system, with this treatment system, we will probably have economy in nitrogen, in fertilizers, and we assess that this is that much. And then the farmers, he adapts his fertilization plan according to recommendation or not, and sometimes he just realizes after if this is real or this is not real. And actually, the soil system is so much complex, and even the variation, this is wastewater and contents of fertilizer is so much complex, and sometimes we make some plan for fertilizer savings, and they are real. And I have an example of a golf course which saves 30% of these fertilizers using reclaimed water. And another time, some farmers, we planned for them to have some economy in fertilizer, but actually they did not see anything. So actually the planification is quite difficult because it's very dependent on the soil. And I think that what we should more consider is more the accumulation in soil years after years. And this is where you should focus more on the research on what are the impacts. And we are building one network of different water reuse system in France, where we can monitor the evolutions of nitrogen and phosphorus in different water reuse sites at full scale. So we can have a bigger assessment, but now it's actually quite difficult. It's a B2B approach because every time we try to modelize and to have a good assessment, it's not that easy.
Very briefly, to understand also the market value of the reclaimed water, it will be important to know how much, in terms of monetary values, farmers are saving. And I tried to find some information on literature, and it's very scattered and not comparable results. We have different values. And for example, there is a JRC report on economic assessment, and they say that 10% of nitrogen could be provided by reclaimed water, but other studies are different. For example, we in Rich Water, we found that in general 30% of the nutrient needs of crops could be provided by reclaimed water, but this also depends on the crop demand, which is different on the content of nutrients in the reclaimed water, which also varies. So this kind of information will be valuable, and unfortunately, we couldn't have these comparable results.
Thank you, Francesco. Thank you, Remy and Rafa. I'm sorry to be cutting this interesting discussion short, but unfortunately, we are behind the schedule. I would like to thank you all here and our participants online, and to remind you that you can find more information on our website, fit4reuse.org, or you can follow us on social media. You also have our email, so you can write if you have any questions or doubts. So we are going to have a coffee break now, and we will be back here at 11:50. Thank you.
Why is it important to tackle the problem of water scarcity? What will we face in the near future if this does not happen soon? What are the possible solutions for this challenge? The Mediterranean region is characterized by limited and irregular availability of water resources. Agriculture is still by far the greatest user of water in the Mediterranean basin, accounting for more than 80% of the total consumption. Climate change and drought events, in a context where water consumption in some places already exceeds the depletion of renewable water resources, will make the region even more vulnerable in the near future. The project FIT4REUSE aims at providing safe, sustainable and accepted ways of water supply for the Mediterranean basin by exploiting non-conventional water resources through innovative treatment technologies on the use of treated wastewater and desalinated water in agriculture and for aquifer recharge, adapted to the Mediterranean context and fulfilling legislative frame and market demands. Reclaimed water and desalinated water contribute to compensate the gap between agricultural water demand and supply and provide consistently high-quality water throughout the year. FIT4REUSE technologies are developed in cooperation with stakeholders of the Mediterranean region and target practitioners, public administration, constructing companies, and water operators through a concise business model, providing guidelines for practitioners and performing a holistic assessment of the use of non-conventional water resources to improve its public and legal acceptance. The project FIT4REUSE is part of the PRIMA Programme, supported under Horizon 2020, the European Union's framework for research and innovation. It counts on 9 partners across 7 Mediterranean countries, consisting of universities, governmental organizations, water utilities, and SMEs. Particularly, the project concentrates on the development of innovative, sustainable, and competitive technologies for municipal wastewater treatment, desalination and brine treatment and disposal, simulation platform, irrigation, The goal of the pilot plant in Granarolo dell'Emilia, Italy, is to optimize and enhance nature-based solutions for domestic wastewater treatment in order to produce an effluent that is suitable for reuse in agricultural irrigation. The pilot plant is located in a small municipality of the metropolitan city of Bologna, and it is intended for the secondary treatment of domestic wastewater through constructed wetland technology. It consists of 12 systems in total, 6 vertical flow constructed wetlands planted with Phragmites australis, and 6 horizontal flow constructed wetlands planted with Iris pseudochorus. These systems will test contribution of different substrates to the treatment performance, also through their combination in series. Besides, researchers from the University of Bologna will test other operational parameters such as the effect of aeration, hydraulic loading rate, and hydraulic retention time on the removal efficiencies of different contaminants present in wastewater. The pilot plant is fully automized and it will therefore allow a more complex monitoring, considerably increase reliability of results, and reduce error probability. The objective of the Greek pilot plant is to produce reclaimed water suitable for irrigation, European Class B or even better, by combining innovative nature-based solutions with nanotechnology. The pilot plant is located in the decentralized municipality of Antissa on the island of Lesbos. It consists of a vertical downflow bioelectrified wetland, followed by a conventional sand filter, a novel nano-zero-valent iron column, and an ultraviolet unit. The bioelectrified wetland is an innovative solution for wastewater treatment that combines the advantages of microbial electrochemical technology with those of constructed wetlands, thus providing a number of benefits such as significantly lower land requirements and the potential for energy harvesting. The novelty is that the materials commonly used for wetland construction, such as gravel and sand, are replaced by electrically conductive materials such as coke, graphite, and biochar that host electroactive bacteria. Accordingly, nano-zero-valent iron is a powerful reagent with high efficiency for a wide spectrum of contaminants, both organic and inorganic. Its versatility is due to the fact that it can remove or immobilize the contaminants through various mechanisms, such as reduction, adsorption, or even oxidation through Fenton-type reactions. The integrated system has plant is used to investigate the fouling reduction device technology. The pilot includes cartridge pre-treatment followed by 2 stages of reverse osmosis desalination, simulating the commercial plant. 3 fouling reduction devices are installed externally to the piping prior to the cartridge filtration or reverse osmosis stages. The fouling reduction devices transmit an electric field into the pipe and the water, with the objective to improve flocculation capability as well as prevent precipitation of salts, organic and/or inorganic material and bacteria. The desalination pilot plant is located at Isbat. It consists of an innovative desalination system combining nanofiltration and reverse osmosis. The pre-treatment module includes a 5, 10, and 20 micron cartridge filters, activated carbon column, and injection of antiscalant to remove impurities and prevent clogging. The hybrid system nanofiltration and reverse osmosis is expected to reduce energy requirements and improves the recovery rate of desalinated water. The brine was used to irrigate medicinal halophytes, salt-resistant plants. This will not only reduce the negative effect on the environment, but also contribute as an additional economic income to the system. Also, solar energy was considered to cover the energy needs of the desalination pilot. The amount of 30-35 kilowatts daily produced was found enough to operate the hybrid system membrane unit. FIT4REUSE simulation platform was designed to simulate simplified models of the FIT4REUSE solutions as a tool mainly for decision-making, suitable to simulate different scenarios for different cases. It enables users to perform dynamic simulations of nature-based and intensive resource recovery solutions regarding the choice of treatment options for different locations and wastewater sources around the Mediterranean region. The platform is capable of simulating single units as well as treatment trains with the innovative solutions of FIT4REUSE. It can be applied to continuously operated units with fluctuating pollutant inputs. The platform is also capable of calculating the reclaimed water quality, the energy costs and carbon emissions of each unit along the total system configuration, and therefore it is a powerful tool for possible energy savings and for preventing excessive carbon emission impacts. The RURO demonstration platform is dedicated to water reclamation and reuse for agricultural crops irrigation. The objective of the platform is to test and to validate solutions for water reuse in rural conditions, for domestic wastewater treatment plant with limited flow and load capacities. The platform is located in Saint-Jean-de-Corny, a town with a population of 1,000 people near Montpellier on the Mediterranean coast of France. Sanitary, environmental and agronomic risks related to water reuse, such as micropollutants or salinity issues, need to be quantified, managed and controlled. Also, the benefits related to water reuse need to be demonstrated and quantified on the field. In FIT4REUSE, different types of flushing methods for drippers and different storage conditions are tested before irrigation of tomatoes and salads in controlled conditions. The tests carried out focus on irrigation management, aiming at answering the questions about the benefits of water reuse in terms of fertilization, how to deal with water quality evolution in open storage, and what are the best on-field solutions to limit drippers clogging. Thanks to FIT4REUSE project, different treatment solutions are being developed and tested in the consortium countries. Application of treated non-conventional water resources for irrigation is being assessed, and relevant stakeholders are being consulted and involved in order to get the most relevant results. Also, regulatory and social aspects are being taken into careful consideration, as the applicable legislation and the public acceptance are crucial aspects of water reuse. Actions and results of FIT4REUSE will contribute to the challenge of closing the gap between water needs and water availability, one of the main issues of our times. Join our cause. Help us reuse to reduce.
Good morning, everyone, and welcome back. I am Viola Benedetti. I'm from the Italian National Institute for Environmental Protection and Research, and I will be the moderator of this session dedicated to the third pillar of FIT4REUSE, which is focused on assessment and regulation. We will have a quite tight schedule. We will start with a keynote speech, followed by a stakeholder video message, and then I will have some questions for you. After that, we will start concentrating on the outcomes of the activities that have been developed within the Pillar 3. So I will check now if we have our keynote speaker, Mr. Faisal Kenini, online.
Yes.
Hi, Mr. Faisal Kenini.
Hi, Viola.
So, Faisal Kenini, he's a senior water expert with an experience of 25 years at international level in Africa and in the Near East region, and a member of the FIT4REUSE External Advisory Board. We are really happy to have you here, Faisal.
Thank you. Yeah, thank you very much, Viola. Just to say that my name is in Italian Chinini, but in French Chenini.
Chenini. I'm really sorry for that.
No, don't worry. Yeah, thank you very much. So I will try to share my my screen.
Yes.
Is it okay?
No. One moment that we check with the service. We are checking, Faisal.
Yes, I'm waiting. I have my screen is ready.
Okay, you can see us.
Yes. But
okay.
you have my screen or you see it?
No signal for now, but we are solving the problem.
Okay.
So you are sharing your presentation?
Yes, exactly. I'm sharing my screen. This is what I am reading.
Okay.
If not, maybe you can share it from your side.
Yeah, in any case, we have the slide, but the problem now is that we can't see you.
You can see me. Oh. Yeah.
Yeah, in a couple of minutes, we will solve the problem.
Okay. So just to say that I'm very pleased being with you and to participate in this Third Water Reuse Day and to take part of this important pillar of FIT4REUSE project. And as I said yesterday, this very important initiative, the water reuse, the third reuse day, this initiative was launched.
Sorry, Faisal, I'm Attilio. Now we see you, but try again to share your screen, please.
Okay.
Sorry about that.
Is it okay?
Try to share your screen.
Yeah, I shared it.
No, you have to push the green button, yes. And then screen, no, you have to push in the screen. So the green button again, Yes, below, yes, the green button. Okay, Faisal. Maybe it's better that we share. We have your slide, your presentation, so we can also.
Yeah. Okay.
Try to put it. So, you see your presentation from us?
No, I have it, so there is no problem. Go ahead. But when I just
okay,
I
so
will
please
let you
tell us when we have to change.
Okay.
Ok, so andiamo avanti. E possiamo cambiare da qua?
Okay.
Non le vediamo.
Okay, Faisal, can you see it?
Yes.
Great. When you want, we can start.
Okay. We can start?
Yeah? Okay. You say next and we change slide.
Yeah, okay. So I'm very pleased to present to you this innovative approach for to unlock the potential of water reuse for agricultural development. So I will start. Next slide, please. I don't see it very clear, so don't worry. So no, it's okay. So this I will start by presenting just a key message from a study that FAO, IFAD, and UNICEF, WFP, WHO developed, and it's a flagship report jointly prepared by these organizations to give a picture of the state of food security and nutrition every year. And the key message is investing in non-conventional water sources such as water reuse and desalination is an increasingly important strategy to face scarcity. So this is the key message. That's why we are focusing on water reuse of these non-conventional water resources. Next slide, please. So the most important thing is to think about vision, to have a clear vision to develop the water reuse project. Having this vision, so it will focus mainly. You hear me?
Yes. Yes.
Okay. So having this vision, it will focus on two important components that we should have the water reuse in the heart of integrated water resource management. This is the first key point to develop this kind of vision. The second point is to have water reuse as sustainable alternative to improve water and food security. You know, our objective to having this vision is to improve water security and food security. Next slide, please. So when we talk about the new holistic and innovative approach that we have developed, we should start by an important component to have a clear picture on the state of the art. We implement the diagnosis and to analyze the situation of water reuse at country level. And the second point, we should develop we should involve all partners, active partners. They are involving directly or indirectly in water reuse sector. So we should have what we call the policy dialogue, mainly to explain the picture of the reuse, water reuse, and to understand the state of the reuse. We are talking the reuse for agriculture sector. Next, please. So the third pillar or point of this approach is to select pilot sites at country level and we should consult and involve, as I said, the active partners at national level, at local level, and also the governmental institutions, the private sector, and the civil society also. So we identify these pilot sites. Normally, they are projects of water reuse, but in different situations. And why we have these pilot sites is to study and to see how to optimize all the system, all the chain of this system, starting from the collection, the treatment, storage, the transfer, and the reuse. When we arrive to the reuse, it's at irrigation level, and we include the irrigation system. Next, please. After that, we should develop what we call the CBA, the cost-benefit analysis studies for these pilot sites. And for each pilot site, we try to develop 3 possible options to improve, to introduce the high technology, for example, for collection, for transfer, and for the treatment also, and at irrigation level. And using these CBAs, we should have the optimal option for this pilot site at country level. Next, please. So when we have identified the optimal option, we should develop a national investment plan based on this pilot site. And at country level, we recommend to launch what we call a national initiative for example, water reuse or non-conventional water. I think the idea is to launch this initiative to have the maximum of active actors in water reuse sector. Let's talk about this initiative. Next, please. What are the objectives of this national initiative for water reuse? First of all, it improves the policy, institutional and legal framework for the management of water reuse. As I said, we should include water reuse in the context of integrated water resource management at country level. Second, this national initiative has an objective to strengthen planning procedures and regulations, also pricing structure, technology, and institutional capacity to promote the use of water, non-conventional water resources. Here we talk about non-conventional water. It could be treated wastewater, it could be drainage water, It could be saline groundwater, brackish water, etc. Desalinate water. And also, one of the objectives is to promote the creation of a water culture based on stakeholder awareness and social involvement on the water reuse. This is very important to develop water culture or water reuse culture at all the levels, high level stakeholders till the farmers and the consumers. And the final objective is to develop a capacity building and exchange and disseminate good practices, information, and knowledge. Next, please. What are I will finish by giving that the components of this initiative. What we have developed is to have here we talk at country level, so we should establish a permanent technical committee on non-conventional water or on water reuse. And we should have, after the feasibility study of the pilot sites, we should have this feasibility study and implement these pilot sites with the optimum of technology, starting from the collection, transfer, treatment, and irrigation. So this should have at country level at least one pilot site that is operating at high technology and giving very important results at taking into account the environmental and social components. And we tried at country level to launch a platform, a collaborative platform for water reuse. And we identify at country level a research center that is very active in the field of non-conventional water or water reuse, and to keep it as a leader at country level, because it's very important that research should follow up, for example, at the pilot sites for following the quality of water, the quality of water reuse, the quality of agriculture production, the quality of soil, the quality of environment, etc. So this is why we are introducing this research center, and we call it Research and Innovation Center. Thank you very much. Over to you, Viola.
Thank you very much, Faisal. So now we have a video message from a stakeholder, and we are glad to have the video message from Olshai Umver, Professor of Practice at the University of Arizona and Senior Advisor to FAO and the UNESCO Intergovernmental Hydrological Program.
I'm very happy to see the successful completion of the FIT4REUSE project, and I would like to share with you some thoughts on the occasion of the session about the assessment and regulation of reuse. This is an area which brings together so many major components of the 21st century water management paradigm, as well as moving the water agenda from its sectoral boundaries to the broader realm of socioeconomics and natural resource management. For the former, that is redirecting our linear use of resources towards circular economies, I'd like to underline the great potential of turning what we have incorrectly called waste into a resource and moving away from the linear paradigm to the circular economy. In the latter, I'd like to bring to your attention two aspects. One, reuse schemes being integral components of nature-based, nature-inspired, or natural solutions complementing gray infrastructure. And two, bringing out very strongly a climate change mitigation component, in addition to the adaptation strength of sustainable water management. The topic of reuse, in my opinion, goes way beyond the realm of unconventional water resources. To me, it tells us how compartmental silo thinking can prevail while we have abundant evidence to the otherwise. Most human activities need and use water and produce wastewater. Our use of water and the subsequent production of wastewater keep increasing with detrimental consequences on our health, our productivity, water and soil quality, and our environment. This has become a vicious cycle, particularly for developing countries. The notion of reuse breaks this cycle, turning this picture around. I'd like to commend PRIMA for focusing on this game changer at a very critical time when we are, as governments, private sector, civil society, and academia, are reassessing why we are so off track in achieving the targets of the Sustainable Development Agenda and seeking accelerators and game changers on the way to the second United Nations Conference on Water after 46 years. Wishing productive, fruitful discussions, which will hopefully help this very important potential to be much more widely understood, recognized, and used. Thank you very much.
We thank very much Professor Umber. We don't know if he is following us from home, but now I would have a question for you. To support the future diffusion of water reuse, it is surely important to look to future possible scenarios. So, please connect again to slido.com or scan the QR code. In a few seconds, we will have the question. So, the question is, according to the United Nations, which percentage of the world's population is expected to live in water-stressed regions by 2050? It can be 20%, around 50, around 70, or more than 80. Let's see. People are still voting. Well, we already have the answers, so the 60% choose around 50%, the 28% choose around 70%. So the majority of you picked the right answer. In fact, in the World Water Development Report released in 2020, the United Nations reports that water scarcity will continue to increase in the future, with provision of around 52% of the world's population living in water-stressed areas. So thank you very much for voting. Looking to these scenarios, it is pretty clear how the future of water scarcity may be an important driver for water reuse. But when we think about water reuse, surely there are lots of factors that can affect future implementation of good practices. So surely regulation is something that is important to be addressed. So the second question is in fact about regulation, and the question is, how many classes of reclaimed water quality are established by Regulation EU 2020-741 on minimum requirement for water reuse? They are 2, they are 4, 6, or 8. That should be pretty easy. But let's see. Okay, people still voting? Voting close? Okay, as expected, the majority of you picked the right question. In fact, the 2020 EU regulation established 4 classes of reclaimed water quality and the permitted agricultural use and irrigation methods. Thank you very much for voting. So now we can go on and we can start with Rémi Declercq, that will talk about us the sustainability and profitability assessment of reuse and desalination solutions. Thank
you. Okay. So, good morning, everybody. I'm Rémi Declercq from Ecofilae, and I will speak about methodology to assess profitability and sustainability of water reuse solutions. Actually, I come from a consultancy company, and over time when I'm working for one client, I got the question, okay, what is the best solution for water reuse? What is the most sustainable one? How much does it cost? And how do I assess all the benefits and all the impacts of water reuse? In this topic, we are not only focused on water use, but also on water desalination. So when you want to assess the impacts, the benefits, make an holistic assessment of water reuse and water desalination solutions, you can both look at the technologies by themselves, are they performant, in terms of can we reach the standards, do we reach the European standards, but you can also look at the other part of assessment, which is more focusing on economic, on environmental, and on social impacts of water reuse solutions. So now we'll be focusing more on this part, and not on the technological part on reaching standards or no. So to do so, in FIT4REUSE, we used 2 main types of methodology. The first one based on cost-benefit analysis, and the other one on life cycle analysis. This is a combination of those 2 tools which give us a holistic assessment of water reuse solutions. Life cycle analysis on environmental impact and cost-benefit analysis on socio-economic impact. To this, we designed fictive, more or less real, more or less fictive case study, we'll see later, 5 case studies in total in 4 different countries. There are 2 case studies in Tunisia, one in Italy, one in Greece, and one in Israel. The objective of the analysis was in a logic, in an approach of eco-conception to improve the solutions, the technological solutions, but also to compare them to business as usual solutions. And in my presentation, I will not have time to talk about all the case studies. I will not have time to talk about cost-benefit analysis and environmental life cycle assessment. I will focus on cost-benefit analysis because I know that costs and benefits are always the most important part for most of the people talking about water reuse. So the difficulty was in FIT4REUSE, we were working on innovative solutions for for reclamation, but not only for reclamation, we also worked on irrigation systems, on storage system. But we are working at pilot scale. It's not interesting to make assessments at pilot scale. It could be interesting at first stage to make a prior assessment, but then the real impact, you can consider it when considering the assessment, the technology, the solution at full scale. So the first scale that we did was to transform, like an extrapolation exercise, to transform pilot scale to full-scale system. And then when we have for each solution, reclamation, storage, irrigation, an assessment of the cost of the infrastructures on the operational impacts for each of the solutions individually, we can integrate them into a territory and consider it how we will combine all those individual full-scale water reuse solutions into a scenario that makes some sense, that is logical on a given territory to reuse water. And to do so, to switch from pilot scale to full scale and to integrate it into a water use chain from reclamation to end uses to irrigation that makes sense, we mobilize some engineering competencies within Ecofile. So when we want to compare and to assess scenarios, let's call them FIT4REUSE scenarios because these are water reuse and water desalination scenarios using FIT4REUSE solutions, FIT4REUSE innovative solutions. We want to compare them to business as usual scenario. In that case, if you want to compare it to business as usual scenario, the question a decision maker may have is, okay, I know that I want to do some water reuse, but which one is the best solution? To do water reuse with FIT4REUSE solution or to do water reuse with other alternative and more conventional disinfection systems or so on. So this is one question targeted in 3 of the case study, the 2 in Tunisia and 1 in Israel. The case study in Israel was more focusing on brine management, while in Tunisia we had 1 case study focusing on water reuse and another one on desalination. But, and often what is more expected from a decision maker, his question is more, if I want to reuse water, is it better to reuse water or not to reuse water? Do I have an alternative to reuse water? Is it profitable and is it? I'm back. It's good. Is it better to reuse water or not to reuse water? So this question, we focused on this, on the 2 case studies in Greece and in Italy. But wondering water reuse or no water reuse, there are a big difference if it is water reuse versus if there is no water reuse in the business as usual scenario, but is there irrigation? Or is there no irrigation, is there irrigation with a conventional resource, or is there no irrigation? Sometimes you want to substitute one resource by another one. Sometimes you just want to create irrigation in a rain-fed system. So for all those case studies, actually, we got different questions targeted, so different indicators for the LCA and for the cost-benefit analysis. I will be focusing on the Greece case study. Why? Because I like highlands, maybe. But in Greece, this is maybe one of the most interesting one. The Greek case study is based on the island of Lesbos, where the pilot sites of the NTUA is implemented. Lesbos Island, it's an island famous for its tourism, its olive, there is a lot of olive trees, and there is a lot of issues with water resources. The question in the Greek case study was to transpose pilots from FIT4REUSE to food scale. So for some technologies, like for the biorectified reed bed filter, it was quite easy because a reed bed filter, it's a high TRL technology, and it's quite easy to transpose it to a full scale. Even the pilot is already really big. So to get data at full scale, tailored for our scenario, it was quite easy. But for some other technology with low TRL, like nano zero valent iron, which are only tested at lab scale, it was more complicated, and you will see that we got high uncertainty and high impact on the project, but that was really interested to integrate them into the analysis as well. So in Greece, we got one business as usual scenario, and in this scenario, as I remind you, there is no irrigation. You got one activated sludge wastewater treatment plant for epuration, and you discharge the water into the creek that recharges the groundwater. Actually, more or less all of the water finishes into the groundwater to recharge it. I forgot to say that in the city where in Antissa, where we built this case study, this is a place with a lot of tourism. So a lot of people, a lot of water during the summer, and much more or less, maybe 3 times less during the winter in the wastewater treatment plant. This is important. And in the water reuse scenario, we combine different technology to reach the class C of the European regulation standards. For that, we combine FIT4REUSE technologies like bioelectrified constructed wetland, nano-zeovalent iron technology to remove micropollutants. So we consider the performances for micropollutants around 60 and 80%. And we added disinfection system, conventional disinfection system like sand filter and UV reactor. To be able to irrigate 23 hectares, we considered also a storage system and a network system for irrigation. So in order to minimize the cost, we first started with a weak storage of around 1,000 cubic meters, which is not that much, but at least it reduces the cost of storage. And we see later that it could have impact on the design of the scenario. But in that case, we could irrigate the 23 hectares of olive crops. I forgot to say that there's many other differences between the two scenarios. And first, you have to know that in a water balance, in biorectified wetland, you lose water by transpiration, while you lose less water into an activated sludge. And in winter, you do not reuse water. You discharge it into the groundwater as well. So it's a very simplified scheme here. And then the question we were asking, is water reuse sustainable and worth it? I could have had using FIT4REUSE technology. And another sub-question that we're asking, is the use of nano-zeovalent iron worth it, and under which condition? So then, considering those two scenarios, the business as usual and the FIT4REUSE, we make balances. Balances for different components, for water, for fertilizers, phosphorus, nitrogen fertilizers, for sludge, for micropollutants, for energy. What comes into the systems and what gets out of the system. Considering not only reclamation technology individually, but the whole water reuse chain that I presented before, my whole scenario. Here I make a focus on water balance. And if you consider, based on a water footprint approach, you consider that all the water that is evaporated or transpirated by crops, by the wetlands, or by crops that are irrigated, actually, this water is lost for the system, is lost for the river basin. So in that case, you don't lose much water in the business as usual scenario, because this is only going to recharge the groundwater, while the groundwater recharge is higher in the business as usual scenario, and lower for the FIT4REUSE scenario. You lose water when you irrigate, considering a water footprint. Because you irrigate, this is evaporated, but you gain yield. This is another impact that we'll see before, but you have to consider from a water footprint approach that you lose water. This is maybe not that obvious. And then we make balances also for fertilizers, and as you can see, to fertilize olive trees, you need to buy chemical fertilizers. But since you make some economy with reclaimed water, you buy less chemical fertilizers with the FIT4REUSE. All of that is based on data supplied by the Greek team from FIT4REUSE. And then we also consider how much nutrients, phosphorus and nitrogen, ends up into groundwater, thus resulting in impacts, environmental impacts. For example, in the FIT4REUSE scenario, there are less nutrients that ends up into the creek and into the groundwater, less eutrophization. But from this balance, where they are done, you can run socioeconomic analysis, cost-benefit analysis, and environmental LCA. But first, you need to do those balances. I will not focus on the environmental impact now, just on socioeconomic analysis. And now with the cost. So I like this is a moment where everybody stares at the screen, because when I put cost on the screen, everybody just stop looking at his phone and just looking at the screen. And on the right, on the left side, you got the business as usual cost. It's a cost analysis. I don't look at the benefits so far, only the CapEx and the OpEx for 30 years. The price cost, which is calculated, is around 3.3 euro per cubic meter. And considering an activated sludge, 98% of the cost is due to epuration of water within the activated sludge. The cost for farmers is more or less important because they have to buy chemical fertilizers. But we have to consider here that we mix two benefits. The one is to epure water, to discharge it, and then the other one is to reuse water behind. And if we look at the right, the cost analysis, you can see that the cost for the wetland, the bioactified wetland, is much lower, the price cost. And then we can see that the price cost for nano-zero material is very high to treat micropollutants. I mean, it costs that much because this technology is very low TRL. Why? And we worked on that with a Greek partner, is that actually you need to run so far with this low TRL technology, you need to supply resins every year at a high cost. So what I propose now is that we forget about activated sludge, we forget about nano-zero-valent iron, because it's not that much efficient so far. We need more work about how to regenerate this resin. And we forget about the reed bed filter, because this is more like for epuration and than for direct water reuse. We focus on treatment for direct reclamation, disinfection, 0.5 euros per cubic meter, and for distribution and fertilizers purchase, which is 0.4 euro per cubic meter. And then, having a look at all the costs, we can have a look at the benefits. And this is the most important part in a cost-benefit analysis, because assessing the cost is quite easy. But assessing the benefits is the most tricky part. Here, in that case study, we consider that the benefits is the difference of olive crops gross margin for farmers. But you have a difference between the two scenarios. In one case, you get yield rain-fed, and on the one, you get yield with irrigation. So the difference between the gross margin between the two scenarios can be calculated and based on the gross margin of olive crops. In some scenarios, this is not the case in Greece. Water reuse and irrigation is seen like more an insurance. It means that during wet years, you don't have impacts on irrigation or not on the yield, but it's only for dry years, let's say 1 year out of 3, 1 year out of 4 or 5. And this is on those years that irrigation and water reuse is really important and beneficial for farmers. In the business as usual, you can also have two options. You can consider that farmers will continue to grow olive trees for 30 years, rain-fed, with a low yield, but they can continue. But you can also consider that due to other impacts, climate change, or I don't know, for any impacts that are coming into the next 30 years, farmers will abandon after 15 years to grow olive, thus resulting into desertification of land and the decrease of farming area, cultivated area. Thus resulting for Greece not only a loss of gross margin for olive, but also directly a loss of agricultural GDP. So this is the indicator we considered there. Then, and I'm finished after this slide, Stevo, we're looking at the result of the cost-benefit analysis. So I remember I focused only on water reclamation system. I forget about nano-zero-valent iron. I forget about activated sludge and reed bed filter. On the left, in blue, you got the business as usual results, which is the net present value, the differences between benefits and cost. And you got something which is profitable, actually. You can continue to grow on olive trees rain-fed. It is only the cost of fertilizers and the olive crops gross margin, which is positive, while the cost of fertilizers is negative. It's a cost. But if you consider desertification after 15 years, you got a scenario which is not profitable. Actually, the reality for the future business as usual scenario, if we do nothing, is somewhere between the two scenarios there. So something not really profitable, but most likely not profitable due to the desertification and loss of land agricultural area. Now, if we look at FIT4REUSE scenario, so the result is the comparison between the CAPEX, the OPEX, the fertilizer purchase, the decommissioning cost, which is more than negligible, and the olive crops cost margin, and we got a result which is much more positive due to the yield increase with irrigation compared to rain-fed systems. So there is a huge uncertainty there, but we'll talk about that later at the end, in the conclusion. And on the right, the orange one is the same calculation, but considering nano-zero-valent iron with the first hypothesis we had. So you know that we still have a lot of work on this technology to make it profitable so far. So at the conclusion, cost-benefit analysis is an essential tool for decision-making for water reuse. Is water reuse profitable or not? In which conditions? Indicators, identification, and quantifications for benefits and impact is difficult. And we need to combine, and this is something that I didn't present here, we combine those results with water footprint, with carbon footprint, and environmental SCA, because as you can see, I didn't talk at any moment about environmental impact. There is need for more replication on other case study, and of course, as you can imagine, there is high uncertainty on some benefits, but there is also uncertainty on the uncertainty values. That this is something that we still need to work on that. And also to consider that, considering nano-zero-valent iron as an exercise here, it's a tool that is really interesting in the logic of eco-conception. And I'm finished. Sorry, Steve.
Thank you very much, Remy. Also, thank you very much for breaking the pointer.
Yes, too much involved. I could talk for hours about that.
No, don't worry. Maybe it's here. Yes. So, great. So now we can start the subsection dedicated to fostering knowledge sharing and exploitation of FIT4REUSE results to support the implementation of water reuse practices. So I call here on stage Antonio Lorenzo that will present the exploitation and transferability of FIT4REUSE results behind the life of the project.
Thank you, Viola. I will see if I can, yeah. Okay, good. I will talk about these different activities we have performed within FIT4REUSE that has to do with exploitation, because, and later transferability of the results. The first thing you have to do is to understand what are the outcomes and the result of the project in order to see how you can later exploit them and transfer. So I will talk about these key exploitable results from FIT4REUSE, the business plans we are developing within Work Package 8, and also about the Horizon Result Booster we applied as a FIT4REUSE project. So it is important to understand that exploitation issues were key, let's say, from the preparation proposal stage. So we were assigning an exploitation manager, which is me. We were including different tasks within Work Package 8 devoted to innovation management, business plan development, and we also include in the proposal a preliminary business plan and also a preliminary list of key exploitable results. What are the key exploitable results? According to the European Commission, this is an interested result selected from all project results for its high potential to be exploited, to be used, to create impact after the project. This could be commercial exploitation, but this could be also some results that are inputs for policy making, for education, for further research activities. So, as I said, there was a tentative list of 9 key exploitable results at the time we prepared the proposal. And since the project started, we also started the monitoring of these results, these key exploitable results. And by month 12, we increased the list to 10. And by month 18, we already had 12. And this is that was based mainly on all the outcomes from the different activities being performed at technical level in the different work packages. And then we had to select also some of then for the business plan development, because we couldn't do business plan for all of them, and also because not all of them were ready, let's say, with TRL high enough to prepare a business plan. So we selected 4 for the business plan development issue. The selection was based on the innovation potential on the TRL at the end of the project, the foreseen and expected TRL, and also on the exploitability potential, as I said before. These are the forecasts selected for the business plan development. The business plan are being developed at the moment. They will be ready in December this year. And as you can see here, we have one on as a technological train to treat and reclaim wastewater with several innovative technologies. Some of them were presented during the conference. The second one is an innovative desalination system combining novel index, different kind of filtration, and also renewable energy to produce desalinated water at a competitive price. We have also the methodology to assess this sustainability. Also, Remy was talking about this, or maybe later you will continue. And also the FIT4REUSE simulation platform that was presented yesterday by Özlem. So we have here the CARES, the selected one for the business plan, and we have the partners, leading partners and partners that were involved in the development. Partners involved are the owners or the co-owners of the different key exploitable results, and they will have access right to exploit them, or they will agree with other partners or other external entities for the exploitation of the results in the market. So as I said, the business plans are being developed. They are deliverable 8.3. And we have got several inputs from the work being performed within the project to develop this business plan. We were preparing some forms for the preparation of the plan for exploitation and dissemination of the project results, which were submitted together with the report, periodic report of the project. We were also working in this horizon result poster forms. I will show you them later. We also were gathering feedback from the stakeholder using the multi-stakeholder platform from FIT4REUSE, inputs from the deliverable that has to do with the legal framework, the cost-benefit analysis that was also just presented, etc. So we were using all these outcome inputs deliverable to prepare the business plan. And I can present now, let's say, some preliminary outcomes from the information we are gathering and including the business plan. As you can see in the table, we have different TRL, this technology readiness level. We have a couple of them, the number 3 and the number 7, which are still low. So as you can see, further research activities, and I will say innovation activities, are needed in order to demonstrate them, to validate them in real environments, to make all these cost-benefit analysis and see how, let's say, efficient they are and if they are really an option for the market. And we have also 2 which are with TRL 7 and 6, so they are a little bit more advanced. In a way, some further innovation activities are going to be implemented. In all cases, the further activities will take into account other value chain actors, like end users, potential clients, in order to, let's say, show in a real environment the performance of the different technologies and the different services. But you can also see here that some of the partners are already saying, okay, we want to commercialize them. So we are going to be the partners that will exploit these results in the market. And the market is ready to receive and is demanding this kind of solutions, innovative solutions that comply with the legal framework, also innovative services and tools to help makers to make decisions on what kind of water source may I use, how can I plan the whole water cycle. So it has been said also during the conference, the population is growing, and in 2015 we are going to be 10,000 million, and many of us, like 66%, I think, according to the United Nations report in 2020, will live in cities. So more infrastructure are to be built on wastewater treatment, and this wastewater treated is the secondary raw material for reclaiming water. So we will have a lot of secondary raw material to be reclaimed and to be used not only in agriculture, but also in urban uses, industrial uses, and also for environmental uses. Regarding the market, you can also see here that the tendency is growing. So for desalination, not only for wastewater reuse, but also for desalination. So the type of solutions that we are developing within FIT4REUSE are those that the market is looking for, okay? And now we'll finish, I think I'm fine with the time, talking about this Horizon Result Booster service. The European Commission, together with PRIMA, is offering some services to FP7, H2020, Horizon Europe, and PRIMA projects to support the projects in all these exploitation issues, which are not always easy to deal with for the academic sector, not always very familiar, let's say. And we decided to apply for one of the services, which is the Business Plan Development Service. I mean, to get the support to draw this exploitation strategy, to ask questions that within the project, when you are working on these technical issues, you don't ask yourself, etc. So FIT4REUSE applied for this support in April 2021, and we started the services from April. Well, we ran the service from April 2022 to July 2022. It was one of the requirements is that you have to select one care for the service, and we selected care 10 because it was the more advanced one in terms of TRL. But we did it in a way that all partners benefited from the service. All partners were invited to the different activities we performed within the service, and we also agreed to follow the same methodology for the other 3 cares. So for the 4 selected cares, we have performed the same, followed the same methodology, and this is the information we are gathering and putting together in these business plans. So the results of having this service in the FIT4REUSE mainly linked to this reinforcement of this exploitation culture within the project and the partners. We gained a lot of knowledge on exploitation and business-related issues, and that was by academic and not academic partner. So everyone was involved in these activities, and I think they were happy to be involved at the end. At the beginning, it was a little bit hard, but later they were happy. And we have got trained in different tools which are very useful, like Lean Canvas, Value Proposition Canvas, and Javelin Board for future activities. So you can see here that we had a couple of workshops with everyone on this business planning, and Lean Canvas, and also the other tools I was mentioning, and also on the exploitation roadmap. So we were gathering information about the results, seeing which point we are, looking at the future to see to where we want to go, and then we were making a roadmap all together. And these are the tools I was mentioning as well, just for you to know. So we were using this Lean Canvas, the use option table, also the risk assessment map, the BOSAT self-assessment tool, which was in fact developed in the frame of another project, and the business plan and exploitation roadmap. And thank you very much. That was from my side.
Thank you very much, Antonia. So, actually, the next presentation is my own. So I will present you the developments in the work about knowledge sharing and stakeholder engagement. So, where are we up to now? Well, we established the Water Reused Forum based in each one of the country of the consortium. We have also developed a multi-stakeholder platform, which is aimed at the creation of a community around non-conventional water resources. We have organized 3 webinars to promote knowledge sharing and collaborative working between different societal actors. Then we have the Water Reuse Day, our main events. So we have organized 2 Water Reuse Days until now. We are in the 3rd one. And as we know, they are aimed at reaching a wider public and at bringing additional stakeholders in contact with the project. So going back a little bit to the multi-stakeholder platform, the platform is intended as a supporting services for knowledge co-production and for operational networking among project partners and relevant stakeholders. Of course, one of the objectives of the multi-stakeholder platform is to reach the widest range of stakeholders, including users and citizens, and thanks to the specific characteristic of the multi-stakeholder platform. So what we have in there? We have a file section that acts like a sort of document repository that is shared amongst the user, that includes, for example, working documents or deliverable produced or other kind of material. Then we have the talk section. The talk section basically allows the user to create thematic forums through chats among them or by thematic groups. So in this case, during the chat, all sorts of documentation can be shared, and then it gets saved in the file section of the multi-stakeholder platform. We also have another tool, which is the survey section. The survey is aimed at collecting information from stakeholders through these thematic questionnaires. We have used these thematic questionnaires to collect several information that were then useful to elaborate our deliverables. So what we have done new are the talks of the multi-stakeholder platform. We decided to make different talks about different topics. So we dedicated the first talk to the FIT4REUSE project. So we shared different kinds of material, a video interview, then some other material about the project. Then we collected some questions in the talk, and then we made another interview to the project coordinator. The second talk has been dedicated to the PRIMA project joint initiative. As you know, we have worked quite a lot with the other project financed in the PRIMA call of 2018 on water management. So we wanted to share the work that we have done also with the users of the multi-stakeholder platform. So basically, we shared the presentation, we share all the documentation that has been elaborated, and then we made some specific interview to the project partners and coordinators to be shared with the users with the platform. So the third talk of the FIT4REUSE multi-stakeholder platform has been about the water solution that have been developed. And then the fourth talk has been dedicated to the foresight exercise that University of Bologna has developed. During the talk, especially in the talk here about the water solution, we also shared the project videos. The project videos are a really important outcome of the project because they are really important for the dissemination of what we are doing. Then the webinars. So we started with the first webinar that has been dedicated to sharing and discussing the results of national water use forums. This webinar has been done also to define the following step that for the organization of the first Water Reuse Day. This was the first webinar of FIT4REUSE. Then we dedicated lots of effort in building synergies among PRIMA projects in the field of water management. So we started to discuss with the other project about our activities and our outputs. Then we started investigating the contribution of the different projects to common issues of interest. It was very useful because after that we decided to present the synergy that we have discussed in an open webinar that was open to the wide public. The webinar, the joint webinar, Solution and Challenges for Sustainable Water Management in Mediterranean Basin, has been really successful. It was held on the 29th of September, and we had more than 200 persons attending to the event. This event has also been a really important occasion to involve stakeholders and experts, and also to have feedbacks by them on the activities of the project and on the barriers to sustainable water management. Then we have the Water Reuse Days. So these are the most important events for our projects, and they are aimed to reaching a wider public and bringing additional stakeholders in contact with the project and further developing its results. So we had the first Water Reuse Day in November 2020. It was in online mode during the Ecomondo conference, and it was an occasion to present the stakeholder engagement results and to introduce the Multi-Stakeholder Platform, as well as the status of the key project outcomes. So in December 2021, we had the second Water Reuse Day. It was held within the EIT Food Worth Drinking Water event, and it was a great occasion to disseminate the project activities and to expand the FIT4REUSE network, because we had the chance to get in contact with a lot of researchers, innovators, entrepreneurs, experts, and policymakers from water-related sector. And so now, today, we are at the third edition of the Water Reuse Day, and I really hope you are enjoying it. Thank you very much. So, now, I give the floor to the last speaker of this session, to Valentina Guerrieri of University of Bologna, that will present future scenarios for the diffusion of water reuse, the foresight exercise. Valentina, the floor is yours.
Me, I'm Valentina Guerrieri. I'm a PhD candidate from the University of Bologna. Coordinated by Professor Matteo Vittuari, that couldn't be here today. I try to be quick because I know that you are tired and you want to go to lunch. Okay, this is the roadmap of the activities performed during FIT4REUSE. The first was the development of an inventory of the current and policy framework. And secondly, an analysis of the perception of this legislative and policy framework, the identification of drivers that hamper, so benefiting from this analysis, the identification of drivers that hamper or facilitate the diffusion of water use solution, then the development of future scenarios, and finally a draft of a set of policy intervention and recommendations. This process is what is called a foresight. A foresight is basically a participatory, system-based technique in which aims to anticipate the future. So basically, it analyzes the current trends, the signals of changes in order to make a better decision for today. It's usually used for policymaking. This live inventory so the first step was to build this live inventory and then to assess the perception from stakeholders of this inventory. and the stakeholders were selected according to the FIT4REUSE quintuple helix model, so benefiting from stakeholders from economic, media and culture, environment, political system, and education. And from this analysis, what basically was the result were the triggering factors, neutral factors, and hindrance factor that could influence the diffusion of water use solutions. So as you can see, as a triggering factor, there was the EU legislation. As an hindrance factor, for example, the lack of financial incentives or the lack of agreement between involved stakeholders. So at this point, benefiting from the perception of the current legislative and policy framework, together with the first result of the preliminary sustainability assessment and the stakeholder consultations held during the water use days, was built this kind of wheel of the drivers of change that could influence the water reuse diffusion in the future. And as you can see, we have used like a qualitative analysis to classify in some way these drivers from a social, environmental, financial, political level, but also technological, so including more internal drivers more than external. So at this point, the main question was, okay, which among these drivers would be the most influential? No, I cannot come back anymore, okay. Which of the precedent drivers would be the most influential in the future? And so for this reason, a consultation with water experts was held through 2 rounds of Delphi. Delphi is a methodologic technique used to reach consensus, and it's usually used in foresight analysis. We had 47 respondents, 5 from Spain, 8 from France, 9 from Italy, 8 from Tunisia, 9 from Israel. So the type of stakeholders were mainly from public authorities, so the 43%, and followed by academia and research center, the 24%, then the private sector, 23%, and less represented were the NGOs and the farmers or farm association. This was a kind of a bias because the consultation was targeted to water experts, and so for this reason we had like more answers from public authorities and academia. And these are mainly the result of the first round of consultation. So these are the 5 drivers that were deemed most influential in the future for the diffusion of water use. As you can see, these are quite in line with the discussions that we have in these days, because we talk about cost-benefit analysis, we talked about nudging strategies. So basically, as you can see, the most influential drivers are reuse cost and financial incentives. Reuse cost because, of course, high cost for farmers, and also from the other side, the farmers that are not willing to pay for water, but also not enough financial incentives for water use. From the other side, we have instead the awareness and the communication strategy. For awareness intended like the mistrust towards wastewater, but also the gap of awareness that there is between different stakeholders, like, for example, farmers and experts, and a bad communication strategy, so the need to promote the reliability of water use solution. So starting from this first round, the idea is to have there is a second round that is ongoing, and we thought, okay, maybe we can benefit of this occasion to share also the QR code to basically answer to the second round. If you want, I will just leave it also at the end. And after the second round of consultation, if we are able to reach a consensus on these 5 drivers, the idea is to build these 4 scenarios that will be like the scenario number 1 will be like the optimal condition. So for example, if we have reuse costs or financial incentives that are maximized, in the scenario 4 instead there is the business as usual situation. And then together with the identification of the drivers, there was also the megatrend identification. The megatrends are like long-term driving forces that are observable now and that will mostly likely have a significant influence in the future. So there were selected megatrends from the JRC Megatrend Hub, and some of them are okay. These one were the one deemed as the most influential for water use. So like the accelerating technological change, aggravating resource scarcity, climate change and environmental degradation, urbanization, increasing influence of new governing systems. And then the idea is that tomorrow we will have the focus group, in which the idea is to co-design some policy recommendation and identify possible intervention to target these drivers of changes. So we will have like a serious game in which we will identify policy intervention that could make the most desirable scenario to happen from one side, and also the stakeholders, they need to cooperate together to reach the target and to target the drivers of changes that we have identified. I was super quick. If you have any question, I would be happy to answer in the Q&A session. And also, if you want to join the second round of the consultation, I just leave here the QR code. And thank you very much for your attention.
Thank you very much, Valentina. So now we have time for some questions. So please, if anyone has questions for the speakers. No, I think it's okay. We can go to lunch. Thank you very much to everyone. And we can close here.
So good afternoon. Welcome back after the lunch. We start again with the session of the afternoon. This session will be devoted to a first round table where you can see seated all the panelists. Now I will briefly present each of them, and then we will have a discussion panel related to the Italian application with Italian stakeholders. Here you can see our panelists. The panelists are almost all the partners, some of the partners of the FIT4REUSE project. They are the PI and also work package leaders. So we have Atef Jawani, you already know him, Ozlem from Turkey, Remy from France, Antonia from Spain, and Simos from Greece. Our moderator, we have the honor to have as a moderator our project officer from PRIMA Foundation, so Marco Orlando, and we will have a discussion about the main outcome of the project and also how this project could be applied in the future and how we could go beyond this project. So thanks and enjoy this section. Please, Marco.
Thank you very much, Attilio, for this brief introduction, yet very comprehensive, because you outlined the main purpose of this session. It's great to have been listening over the past 2 days to all the results that have been presented. I think now this session can work as a first step for the consortium to look behind, to see what was done, what worked, what didn't work, what can be, let's say, some inspiring ideas maybe for the future. You've worked together, you build a partnership which is strong, and possibly in the future you will be trying to valorize the results of FIT4REUSE, further progress, and so on. So I've been tasked with this duty of moderating this session. I count on your collaboration because I think we're 5 minutes late, so we have about 55 minutes, 1 hour, to reflect, of course, on the outcomes, challenges, insights for the future, following again the work that has been done. And I ask you to be concise in your answers. You have about 3 minutes each. I will be vigilating because I have to make sure we are not too late. So, of course, Attilio mentioned already what we will be discussing. I think we can start from the challenges that you encountered over the past 3.5 years. I have to congratulate also the project for dealing with the pandemic in such an efficient way. So, of course, challenges you were multiplied by the pandemic that you experienced. Okay, so let's start from the challenges encountered and the lessons learned. I think I will just call the speakers, I mean in the order where they are sitting from left to right. So, of course, the last to speak is, of course, not less important than the others, Atef. I will start from Simos. Simos, a brief reflection from your perspective on challenges encountered and lessons learned.
Sure. So thank you for the invitation to be here with you. I think the main challenge is to do more than the implemented work and stay within the budget. Sorry. But to be concise, as you asked, I think that first of all, nature-based solutions are not mainstream solutions, okay? And they have been regarded for a long time as end-of-pipe solutions that are not contributing to circular economy and water reuse. So I think one key issue and challenge we had was to show that we can achieve reclaimed water of good quality within what is specified as at least Class B or Class C within the European regulation, using nature-based solutions, different configurations, and even improved performance with integrating nature-based solutions with other intensive solutions. I think this was a key aspect that Fit4REUSE has provided a lot in terms of, and we'll discuss later about this. The other thing is in terms of challenges, because we had also technologies that were at a low technology readiness level. And the challenge was there to show, first of all, that the technology, the process itself, is feasible. And then also we had to provide some insight that how we can upscale it and how these results can feed into the cost-benefit analysis, into the life cycle assessment, because it's not easy when you are using technologies and you are trying technologies in the lab or in a small pilot to actually then go several steps beyond that and show how this can actually have a good environmental, social, and economic performance.
Excellent. I think these are very important points that provide the partners with some food for thought for the future activities. Thank you. Now I will give the floor to Antonia. Antonia, what's your perspective?
Okay, thank you, Marco. So I will talk a little bit about exploitation issues because that was my main role in the project. So there were some challenges at the beginning. FIT4REUSE is a research and innovation action. So it's a little bit more, let's say, far from the market than an innovation action. So it was not easy for the partners to see this future exploitation, because as mentioned also by Simos, TRLs were low. So, but you have to really work, insist and resist and work with the consortium. Another challenge was that the consortium, the majority are coming from the academia. So it's also, I mean, all these exploitation business-related issues are not that familiar for them. So it was challenging from the beginning to build this exploitation culture, as I mentioned before, among all the partners, and to have this common vision on the need to use the result, to have a plan, an exploitation roadmap, to create the impact that you are expecting from these projects. Regarding this lesson learned on the work that has been done with the partners in exploitation, innovation management issues within the project, I would say that we did it very well starting very early with these exploitation activities. Everyone was getting familiar. I mean, at the beginning it was hard. It was something very far away from the daily work. But we did it in a way that everyone was getting on it. And also understanding the importance of dealing not only with these technical issues, the pilot and publishing and the rest of the things that are in the academia daily work, but also on thinking in the future. So that was a very good theme, involving all the partners, and that, in fact, they have been involved in this business plan development issues. So, yeah, that's it.
Okay, that's very nice to hear. I'm happy also that you identified several key exploitable results, then you focused on 4 of them, and that you worked on the business plan, so it's very promising for the future. So not everything can be done in 3 years, but we will see in the future how things go in this direction. Thank you, Antonia. And I will move to the next speaker, Remy. So can you provide us with your thoughts?
Yes, thank you, Marco. For me, I will talk from my point of view, just to remind that we are a consultancy company working on water reuse. So we got clients, which are industries, which are municipalities. And from my perspective, from my point of view, one of the main challenges that was partly targeted by FIT4REUSE was to propose new solutions in terms of treatment, of reclamations, more effective one, more extensive ones. So that's why this project is almost half of the technology tested are reed bed filters or constructed wetlands. But that was to have new technology, new solutions performant to reach the European standards, to propose, and to be able to propose them, to describe them, and to have proof for their performances, and to carry them out, to help them to get out to a lower, higher TRL, to propose them on the market. And I think we moved on well with that, but that was one of the big challenges for me, and that this project helps us to achieve. And another challenge that we are facing, and that we targeted here, was on how to find solutions to support our clients with a method to assess sustainability and profitability of water use. And for this, we're still lacking of method. We've worked on that, on the cost-benefit analysis, on LCA, but this is something that is really a real challenge to assess the benefit and the impact of water reuse and water desalination solutions. And last but not least, when we irrigate crops, when we want to reuse water on small scale, small wastewater treatment plants, it's not the same as reusing water in big wastewater treatment plants in terms of profitability, because you get less water, so in euro per cubic meter, it's less, it's more expensive. So we need to find more solutions and more extensive solutions, more low-cost, low-tech solutions, and this is something we are heading toward, and I think this is one of the major challenges for the future and still for water reuse and water desalination.
Excellent, very concrete points as well. I mean, thank you. Özlem, your perspectives on the challenges and lessons learned.
Yes, well, we have been working a lot with the technological solutions, both the intensive ones and the nature-based solutions. Well, one of the most challenging points during the pandemic was the actual physical integration of these pilots, because, you know, we can develop technologies, as Simon has already mentioned, in our labs, but then carrying it to a scale where it can be implemented in pilots near wastewater treatment plants, it's not that easy. So with some of the pilots, we had to, you know, change our plans a little bit. We have to, but we have managed very well to integrate and have the pilots and show that those pilots are really working and having achieved these nice results. And one very big issue for our team was that during the pandemic, the wastewater transportation was a really big issue, and nobody allowed the transportation of wastewaters. And for the toxicity tests, we had to carry them to Turkey, Istanbul, but it was not possible for all cases. So we made a new plan, a plan B, and we had to travel ourselves to have the toxicity tests on site. So, but this could be only, you know, overcome with the collaboration of partners. Everybody was so dedicated in the project, I must mention. So this cooperation worked very well, and we could achieve all we have planned and promised in the project. And one thing about modeling I must also refer to, it was that we have so many technological solutions and different data sets coming from all those partners for a 3-year study in the field or in the lab. So having those data and working them with the simulation platform was not that easy, because everybody has a different set of data, and we try to understand what those data meant to make it better and to work with it better. So, but this gave us good strength, I must say. This way we have learned how to make our model more flexible and have issues about the model structure. We had to change some issues about the model structure so that the model and the simulation platform has become more flexible. So we have benefited from this disadvantage in this project.
Excellent, yes. I think we have to congratulate the project for the adaptive capacity that you demonstrated, because I remember discussing these issues with the coordinator when the pandemic started and disrupted basically everything, so well done. Okay. And again, one last perspective on the lessons learned and challenges from Atef, not last but not least, of course.
Okay, thank you. My micro is number one. My micro is number one. So it's the same to be the number one or the fifth.
We will start for you for the second round.
Actually, I share the same ideas with my colleagues about the challenges. Of course, we agree because we share the same challenges. But in addition, for ISBAT, as a partner, for Tunisian partner, we were involved in wastewater treatment and brackish water desalination. And in addition to all what was said, I would say that we faced also other technical and non-technical challenges. Technical challenges, since in Tunisia we are not used with constructed wetlands as a nature-based solution applied at a wide or big scale. We have some experience, but it was very reduced in terms of number and of scale. And also for anaerobic treatment, for example, there is no running any anaerobic treatment for wastewater treatment, urban wastewater treatment in Tunisia. So from technical point of view, it was challenging for us to design and to install the pilots and to run the pilots. In addition to other running the pilots during the pandemic and to provide continuously feeding and to face also some fluctuation in the quality and characteristic of water. In addition to all that, we faced also some non-technological challenges. I mean mainly the regulatory framework. We don't have the same between the northern part of Europe and southern part of Mediterranean area. So how to standardize, how to look for synergies between us, to have results that can be exploited both in the in the northern side and in the southern side. Of course, in Tunisia, regarding desalination, we are using desalination more and more, and the problem is always the problem of cost and the problem of brine management, especially for the non-coastal areas where it is not possible to put the brine directly in the sea. So I think these are the main challenges that we were facing. Thank you.
Okay, I think very valuable lessons learned for the future projects, maybe that you would like to cooperate within. And I think we can now move to another interesting topic, that is what were the main achievements and results from the FIT4REUSE project. I mean, there have been presentations over these 2 days. Maybe we can have one final reflection also to pick some important result achievement that can be further considered for the future. So I promised you, Atef, that we would start from you for this round. No, please go ahead. Your perspective about the achievements.
Okay. Regarding the achievements, I think that at the end we were able to establish one train of treatment combining anaerobic and nature-based solutions with disinfection that gave the good results that could, so the quality of water could be reused in agriculture, even to satisfy category B of treated wastewater in Europe, so the Tunisian standards and also the European standards. Also, we were able to integrate several innovative technologies. So we worked on different things, the substrate, the addition, the type of plant, the addition of adsorbents, the disinfection. But I think that we succeeded to have, by mixing the substrate, to have good results, for example, between gravel and cork. Also the addition of low-cost material to adsorb emerging pollutants. I think that this is also good for us to find this quite cheap and easy solution for these kind of contaminants. Our also experiments about the addition of what we call plant growth promoting bacteria showed clearly that we enhance the quality of water, and this is maybe indirectly through the enhancement of plant growth. So we have much more better plant growth and indirectly better quality of water treated mainly by constructed wetlands. In terms of desalination, the combination that we test, combining nanofiltration to reverse osmosis, allowed us to have quite good quality of water with lower energy requirement, which opened the field to the use of this desalinated water for irrigation, because up to now, because of cost, we are using desalination only for drinking water. It is very, 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 very expensive for us. But I think that with these findings, where we were able to reduce the energy consumption through the combination of nanofiltration and the reverse osmosis, in addition to the use of photovoltaic panels, the system was quite autonomous. So we can think that this would be feasible to think about the reuse of desalinated water in irrigation. These are the main findings, I think, for Tunisian partner.
Okay, excellent. Thank you very much. And I would like to hear now from Sulem.
Yes, in terms of the achievements, I can say the integrated pilots that have demonstrated that we can achieve really good treatment with both advanced and nature-based solutions, present great showcases, because, you know, sometimes no matter how good you explain that the technology would work and make the wastewater reusable for irrigation or for aquifer recharge, it doesn't help. You have to show people. So having the pilots working with real wastewater is one of the biggest achievements, I could say. And in addition to that, with the simulation platform, we have the tool now to replicate all these solutions at different places, and at least for a beginning decision support tool, we can use this simulation platform, and the results are really good in terms of predicting the behavior of our pilot systems. So those achievements are really adding a lot to the solution pathway to show the users that these solutions are actually working, and they could also replicate them in their cases. Those are really great achievements, I would say.
Excellent, thank you very much, and I'll give the floor now to Remy.
Wait. Okay. The great, best achievements I see, if I get back to my point for the challenges, I mean, from my point of view again, now, since with FIT4REUSE, I'm able to propose more solutions of treatment, of reclamations, treatments, individual treatments, but also complete chains to reach different level of classification in the UE regulation, Class A, Class B, Class C. I know their advantages, the breaks that still remains, the cost, thanks to the cost-benefit analysis, the cost analysis. And I'm able to propose them. I've got new solutions to propose, and to me that's really good achievement for such a project, which is very based on innovation and on research. Another one is more focusing on irrigation solutions. I mean, we got now a guideline for irrigation practitioners. So they know, with these guidelines, they know which parameters they should target to assess, to better monitor the risk assessment on salinity, on agronomic impact, environmental impact, to assess better the fertilizer's properties. So with these guidelines, I think this is not a holistic one, but at least this is a minimum you should follow to monitor the risk. And this is, I think this is a good, great achievement as well. And the last one for me is about the method for holistic assessment, combining cost-benefit analysis, environmental SCA, water footprint, and carbon footprint, which gives a good overview of the complete water use chain. And to me, that's still some work to do, but it's a good achievement.
Yes, I like in particular, it's very interesting to hear from the different partners, because it seems that based on the work that you carried out, I mean, you worked together jointly on several work packages, someone was more involved in some specific work, but there are some takeaway lessons from each and every one of you. So not only for, in terms of developing the solutions that we should work to make sure that such solutions like for example, the platform will be used in the future. But of course, you are now able also to identify some possible steps for yourselves, how to improve this work in the future. That's very good. And we will follow with Antonia now.
Okay. I think, main achievements, or the achievements have been delivered by the project under some difficulties, because we have had some difficulties in this COVID time. Is mainly based on a committed consortium. I think Özlem was already saying this, and a great coordination. So this is the main achievement, and under these conditions, when everything was a little bit more difficult than before, we as a consortium were able to deliver what it was expected from us. So I think this is the main general achievement I would like to mention. But based also on the different presentations we have here yesterday and today, we are also within the project creating the evidence that the market is demanding. So even though some of the project results are not at TRL, high TRL, some of them are low, some of them are higher, but we are creating evidence. So next step will not start from scratch. So we have already done some work, and this is going to continue and probably deliver some solutions, technologies, innovations to the market, which are needed and which are demanded. So I think it's another achievement. So in terms of exploitation, I was talking, we have identified and characterized different innovations. Some of them combined are also these key exploitable results, which has been characterized as well. And we have been able to say go or not go for some of these care, because they were in a, let's say, lower TRL, but it doesn't mean that they are not good results. It's just they are there, and next step we will see. And we have also, we are going to deliver in 1 month these business plans with this road to market, and this is what we understand that is the pathway to the impacts. So we are expecting. Yeah, that would be from my side.
Okay, and we have some concluding remarks on these topics of the, let's say, the successes, the results from CIMOS.
Yes, I think the results, the technical results were very nicely summarized. I won't go again repeating, and I will put something a bit higher level. FIT4REUSE, and I think this is true for all the working groups, have given us the opportunity to hire high-quality researchers and maintain them in our country, maintain them in the Mediterranean. And this brain remain is very important for our groups, I think. For example, in our group, we'll have a couple of PhD theses that come out of the work that has been done in FIT4REUSE. And I'm sure that this is true for the other research groups here. So this, I think, gives also a good pass on continuing the project and our discussion about the potential extension of PRIMA and the calls for the years to come. And I think this is a very strong point. The achievements of this project give a very strong argument to continue the PRIMA also for the next years, because I know that from the initial day that there was a launch in Greece about the PRIMA some years ago, that there was a quite fierce opposition by some countries that didn't want the PRIMA to go through. And I think the achievements of this project give exactly the opposite argument of why we should continue with these kind of projects.
Okay, thank you, Simos. And I think it's a relevant point, not strictly connected to the single project Fit4Use, but I mean, as you said, and yesterday I stressed this when there was this introductory roundtable. I stressed also the importance with regards, to valorizing the implementation of water use. That there is a need also for capacity building, and capacity building happens also through PRIMA projects, even though it's not the main orientation of the program. And knowing that there are young researchers, that are working with, as we saw yesterday and today, working within the margins of these projects is very encouraging. Also because, let me stress the importance of what we try and do to also, it's not the pathway to exploitation, to impact, it doesn't happen immediately. So there are other important things, like the generation of new knowledge that has to be valorized. And of course, what we are very focused on trying to facilitate this knowledge sharing across the borders, okay? Between countries from the northern shore, the southern shore, and the eastern shore. So very good point. Thank you for raising this point. And time-wise, we are doing quite well. My notes here say that by 15:07 we should have finished the second round of discussion. It's 15:06. So thank you very much for being this efficient, which gives us approximately 20 minutes for the last round of discussion, which is quite interesting actually. And I've been speaking with Attilio yesterday and today about maybe the future perspective. So now we can hear also from your project partners about this issue. Again, we are quite comfortable with time. We have about 20 minutes, so we respect this indication of 3 minutes. We see if we have some time at the end just for some final remarks. And if Atef agrees, I will stay with Simos for the time being. Simos, go ahead. Now, this last round, yes, future perspectives.
Mm-hmm. So let's start from the technical part. We have some technologies like the molecular improvement polymer and the nano-zero valent iron that have been tested at a rather low technology readiness level. So I think for these solutions, the way forward in the coming years would be to test these at a higher, at a bigger scale, high TRL level. So Fit4Use has shown the way that these processes actually work. And, but we cannot go full scale. You need to fill in the gap in between. So this is one point. The other point is related to policy and legislation. So, and there is pending the REFIT, the new Urban Wastewater Treatment Directive, and I will go into a couple of, because there are the propositions there regarding energy neutrality of wastewater treatment plants at big scale, let's say. So within Fit4Reuse, we have shown technologies, mainly anaerobic processes, but also wetlands that are a passive system and a combination that contribute towards this stream, that we can recover energy from sewage and we can use passive treatment technologies that are of low energy requirements. So one good point to feed in with Fit4Reuse is this one, in terms of the energy balance of the wastewater treatment plant. The second point relates to emerging contaminants. Big plants will be required to adopt in the future advanced processes to eliminate, I think, more than 80% key emerging contaminants. Also there, these technologies that we have discussed, MIP and NZVI, have shown that we can eliminate targeted micropollutants by employing them. So also there is big interest on these.
Okay, very good. And Antonio, according to you, new ideas for topics to further explore, themes from Fit4Use that can be further researched, how to build on the experience?
Okay, I would say that the strategies are a little bit different between, depending on the TRL of the different technologies. If we focus on these key exploitable results, so I mean, further research activities are needed, especially for those that the TRL are low. And I would say research and innovation activities, and for the TRL, the higher TRL, I would say innovation, more innovation projects than research projects in terms of filling this gap in between the pre-competitive to a competitive result that could enter in the market. I think it's also important to take into account that these further activities, research and innovation activities, should also involve some end users, some potential clients, some policymakers. I mean, also because when they are in the consortium, they get more committed, and this is also kind of key for succeed and real implementation after the projects are over. So I think this is key also to involve, and then to have the possibility to do this demonstration tasks, these validation tests that are needed, again, to create the evidence for penetrating in the market, or, I mean, offering new services that would support policymakers to take decisions or whatever. And I think it's also very important that we are not only talking about technologies, systems, innovations, we are talking about contributing to the sustainability of the food system. And it was already a wider and holistic approach within the FIT4REUSE, but we can go further, link it to energy, link it to this WEF and nexus of water, energy, food, ecosystem, trying to understand the whole thing in a more holistic way, and I think for further activities we should have this into account, how to embed these results in a wider context. And well, I think we have been already checking some Horizon Europe calls, topics to see how to continue with the whole group or with part of the group, depending on the different cares, and also PRIMA calls. So, I mean, I think we are quite active in order to go on working together, because we have had a lot of fun and we were quite effective working together. So, yeah, we are also checking these already to see where to go and how.
Yes, I have no doubts I will see new application and I will recognize some names, so well, good luck. And of course, if I may raise another point, what we are proud of at PRIMA is that we are bringing together people from the community of practice, so-called community of practice. So there are, maybe we can call them some twin projects, okay, where some of you are involved, PRIMA funded by other initiatives. So of course it's also good that you explore synergies with ongoing actions, and especially for the Nexus. There are some other PRIMA projects, so the legacy is not limited to another project, but it also, let's say, the FIT4REUSE blood runs through the veins of other projects, twin projects, we could say.
Yeah, maybe I can say something on this, because I wasn't here writing, but I forgot to say it. These cross-fertilization activities, we are also making some bridge to other projects, also to try to understand how we can benefit from the results, and how can they benefit from our research as well, in order to push this, this transition to this more sustainable agriculture, especially.
Please, that's very important. Thank you. And I will move back to Rémi for his perspective on this point.
Yes, so I won't repeat, but I totally agree with Antonia Simos. I think for Pillar 1, for the technology development, of course, we should increase TRL for the technology. But that seems promising, and that we have very low TRL here. And on the others, we should work on the entrance to the market, which is something really key, and maybe work on diffusion, how it can be broadcasted and diffused into the network of technology suppliers. This is a good maybe a next point for another project. And of course, we should not forget to test new technology, new solutions every time, because the perfect solutions still do not exist, but every time we're getting closer and closer. And focusing more on replication and diffusion, I think we made good connection with, for example, with other projects like Suwanu project. We made good connection with this type of project, and maybe we should take some feedbacks from them on how to broadcast our knowledge, how to disseminate better to the field, to the operational stakeholders. And getting back to the method for holistic assessment, I think that this method is quite robust, but we need to repeat it in different contexts, to apply it to real case study, full-scale study, because here this was we work more on half real, half fictional case study because we wanted to develop indicators as well. But now we need to replicate it. We already started at Ecofly, but it needs to be, even if it's a complex methodology, it needs to be broadcasted and to be disseminated as well. To be sure that when you consider a water reuse project, you don't only consider the cost, because often this is what it is easy, this is what you look like. Okay, water reuse cost that much, the other solution costs that much, yes, but what are the benefits, the impacts? And for this, often people are a bit lost, and we need to push forward that fertilizer savings, of course, but of course gross margin for agriculture and social impacts and benefits. And for this, we should continue to work on indicators and to promote this type of approaches, because, and I will finish like this with that, but we realize that often water reuse is not the good solution. Very often, and even in France, I see that now we have to, using the same type of method, we have to highlight that some ideas on water reuse, no, they are not maybe the best idea. Maybe you should not do water reuse this way, but this way, or maybe you should not do water reuse. You have got better solution, and this is actually, I think, a key point, considering my point of view from France, is that now more and more water reuse projects will start growing, and sometimes we should remain careful about where to implement it and where not.
Okay, very wise words. I like this perspective. I like also to see that the ambitiousness of the project, which we saw on the paper when we selected the proposal more than 3 years ago. I mean, after 3.5 years, you are also now thinking about what is next. So very good. And we will continue with our friend, Muslim.
I agree that we should have more innovative solutions in the future. We could have, of course, the ones that we have developed have to be explored more. And what we have achieved with the integrated systems, I have to emphasize that having them really running is so hard, because you have to find a treatment plant operator who would let you in their facility, build your system there, and monitor your system there. You would go in and out of the system whenever you need that. That's not easy. Finding the pilot sites, etc., it was not easy. So I think we should keep the pilot systems running and probably develop them with enhancements and turn them into living laboratories, because this is really extremely important. You know, sometimes one site visit can change the total perspective of a water authority. I mean, I have experienced this in Istanbul. We have been trying to explain how innovative solutions could be applied to wastewater treatment solutions in Istanbul, and the water authority rejected that for almost 3 years each time we had the meeting. But then they had one site visit to actually where it is implemented, and they suddenly changed their perspective. So, I mean, just 1 week of site visits was enough to convince them that those innovative technologies were really working. So therefore I find it really important, if we want to go to the market and make these technologies usable for reuse options, for farmers, for municipalities, we should keep them as demo sites and as living labs, try to explore them more and more. And of course, for the simulation platform, we could extend this as Remy has already suggested, beyond the technological solutions, but we can extend the simulation platform to have all the value chain for water sector so that we can have a more holistic picture of the reuse options and alternatives.
Okay, great. No, I'm happy that it's a research and innovation project. It's defined, but you generated many ideas that are worth exploring in the future. Atef, seems like we are close to finishing this session. We still have time, so I turn to you for the last comments on this topic.
Okay, thank you. So regarding the future perspectives, of course, as said Simos, some technologies are at low TRL level now, and they prove they are interesting. So I think we need opportunity to prove that these technologies are robust, that we can implement them at higher scale, and to integrate them in, let's say, full-scale system running for longer time, and to prove the feasibility and the feasibility of the technologies, and that these technologies are really robust. Another aspect, I think, is to work on the uptake of these solutions and the replicability of these solutions. I think these main 2 points are very interesting for us, because we have some technologies that they are working, of course, but how to make this, how to involve more stakeholders, you know, with the pandemic, involvement of stakeholders was not easy, but how to work on this to ensure the uptake of these solutions and the replicability of these solutions.
Okay, that's a very good point, because what we would like to see is, you know, that the solutions that are generated at a point are taken up by society, by farmers, that you have an impact, of course, on I mean, we've been discussing about policies, about integrating water reuse into integrated water resource management plans, okay, penetrating more the political agenda so that it's given this topic the importance that it deserves. So, I mean, there's a lot of work ahead, it seems, but I think this was a very interesting session, because I mean, you were kind of bringing different perspectives based on what you were responsible for in the project. I think all the different pillars of this project were kind of explored, from the reflections on the technology, the technological solutions, on the modeling and integration, also the application and assessment. I mentioned the how to exploit further the result in the future. So it was very encompassing, and I think you have many things to discuss, maybe, starting from tomorrow, and to guarantee that the legacy of the project is kept alive. I think we are a bit ahead of schedule, and I mean, it's fine, I think. I don't know if there are some remarks, additional remarks from any of you. Otherwise, maybe we can ask the project coordinator if he wishes to say a few words, just to conclude the session. Because okay, unless, do you have any final remarks that you wish to add?
Not in the panel, that's why we are not late.
No, Francesco was very efficient also before when he intervened. I think we also have to say thanks to Viola, who provided a lot of support in the, I don't see her in the, here, but I think we have to say a big thanks to Viola, because she coordinated a lot. She was behind the curtain, but she helped out with the organization of this session. So thank you very much again, and I'll give the floor to the coordinator, Attilio.
Only a few words. I have to thank really Marco for his moderation and for being with us all this event, but I have to say all the events and also the meeting of our project, Marco was with us, and all the PRIMA Secretariat was close to us to solve all possible problems, even during the pandemic. It's not so easy. It's easy to solve. Thank you, Marco. Thank you, all the friends and colleagues from the project. I believe we discussed it yesterday with Marco that you have seen that we have several ideas or suggestions to go beyond the project, to continue the activity of the project. We said yes. We have seen yesterday Angelo Riccaboni, the chair of PRIMA Foundation, also asking for a possibility to go beyond this project to have a real application, a bigger scale of this project. So, as I said yesterday, all the consortium, all the partners are ready to start thinking again possible future collaboration within PRIMA, above all, but in other possible programs. I think that this is, from my point of view, that for sure is a part of the reality, but from my point of view, the real added value of this project, of this program, PRIMA, and of our cooperation is to create a group of researchers that are very strong in the as I say, in the activity, in the collaboration, in the joining the ideas, and I believe that FIT4REUSE could really go beyond this project. So thank you so much to all of you. And I think that now it's moment for another coffee break, just to replace the seats here. And Özlem, please.
Just one word. I think this project is a very good example of a good collaboration between partners, but it's not all that. It shows us that a funding institute should also have strong relationships, good collaboration with also the project officer, the project coordinators. So I would also like to thank PRIMA because, sometimes you see some funding institutions pulling you back with so many rules, so many procedures, and but I hope this will continue like this with PRIMA, and this is also a very good example. Thank you.
Thank you, Özlem. All of us agree with your statement. So, thank you very much, and enjoy the coffee break, and see you in 20 minutes, I believe. Yes, thank you.
Not happen soon. What are the possible solutions for this challenge? The Mediterranean region is characterized by limited and irregular availability of water resources. Agriculture is still by far the greatest user of water in the Mediterranean basin, accounting for more than 80% of the total consumption. Climate change and drought events, in a context where water consumption in some places already exceeds the depletion of renewable water resources, will make the region even more vulnerable in the near future. The project FIT4REUSE aims at providing safe, sustainable and accepted ways of water supply for the Mediterranean basin by exploiting non-conventional water resources through innovative treatment technologies on the use of treated wastewater and desalinated water in agriculture and for aquifer recharge, adapted to the Mediterranean context and fulfilling legislative frame and market demands. Reclaimed water and desalinated water contribute to compensate the gap between agricultural water demand and supply and provide consistently high-quality water throughout the year. FIT4REUSE technologies are developed in cooperation with stakeholders of the Mediterranean region and target practitioners, public administration, constructing companies, and water operators through a concise business model, providing guidelines for practitioners and performing a holistic assessment of the use of non-conventional water resources to improve its public and legal acceptance. The project Fit for Reuse is part of the PRIMA Programme, supported under Horizon 2020, the European Union's framework for research and innovation. It counts on 9 partners across 7 Mediterranean countries, consisting of universities, governmental organizations, water utilities, and SMEs. Particularly, the project concentrates on the development of innovative, sustainable, and competitive technologies for municipal wastewater treatment, desalination and brine treatment and disposal, simulation platform, irrigation, The goal of the pilot plant in Granarolo dell'Emilia, Italy, is to optimize and enhance nature-based solutions for domestic wastewater treatment in order to produce an effluent that is suitable for reuse in agricultural irrigation. The pilot plant is located in a small municipality of the metropolitan city of Bologna, and it is intended for the secondary treatment of domestic wastewater through constructed wetland technology. It consists of 12 systems in total, 6 vertical flow constructed wetlands planted with Phragmites australis and 6 horizontal flow constructed wetlands planted with Iris pseudochorus. These systems will test contribution of different substrates to the treatment performance, also through their combination in series. Besides, researchers from the University of Bologna will test other operational parameters such as the effect of aeration, hydraulic loading rate, and hydraulic retention time on the removal efficiencies of different contaminants present in wastewater. The pilot plant is fully automized and it will therefore allow a more complex monitoring, considerably increase reliability of results, and reduce error probability. The objective of the Greek pilot plant is to produce reclaimed water suitable for irrigation, European Class B or even better, by combining innovative nature-based solutions with nanotechnology. The pilot plant is located in the decentralized municipality of Antissa on the island of Lesbos. It consists of a vertical downflow bioelectrified wetland followed by a conventional sand filter, a novel nano-zero-valent iron column, and an ultraviolet unit. The bioelectrified wetland is an innovative solution for wastewater treatment that combines the advantages of microbial electrochemical technology with those of constructed wetlands, thus providing a number of benefits such as significantly lower land requirements and the potential for energy harvesting. The novelty is that the materials commonly used for wetland construction, such as gravel and sand, are replaced by electrically conductive materials such as coke, graphite, and biochar that host electroactive bacteria. Accordingly, nano-zero-valent iron is a powerful reagent with high efficiency for a wide spectrum of contaminants, both organic and inorganic. Its versatility is due to the fact that it can remove or immobilize the contaminants through various mechanisms, such as reduction, adsorption, or even oxidation through Fenton-type reactions. The integrated system has been set in operation and is routinely monitored in order to achieve optimum conditions, thus supporting the production of reclaimed water suitable for irrigation purposes. Low-cost and energy-saving experimental wastewater treatment pilots have been designed and implemented separately or as integrated systems in relevant environment and run with real wastewater at relatively high flows. The pilot plant, using nature-based solutions as vertical and horizontal constructed wetlands for wastewater treatment, is located in Wastewater Plant Treatment El Menza. Additional technologies will be combined and integrated in order to enhance the removal of pharmaceuticals, emerging pollutants and pathogens, and to recover nutrients and energy. Fixed bed adsorption using various inexpensive and natural adsorbents, clay, olive seed, date seed, and perlite, will be added before the discharge of wastewater in order to enhance the removal of pharmaceuticals and emerging pollutants, for example, bisphenol A and diclofenac. Ozone and UV irradiation technologies to remove pathogenic bacteria will also be assessed. A collection of plant growth promoting PGP bacteria was selected and will be integrated with constructed wetlands to remove micropollutants, diclofenac, bisphenol A. The upflow anaerobic sludge blanket pilot, an anaerobic process for intensive wastewater treatment, is installed in wastewater treatment plant Shotrana. It is designed to be tested and started up with static biofilter as a pre-treatment stage for total suspended solids and chemical oxygen demand removal. It contains 2 tanks as conditioning tank and UASB reactor assembled as a closed-loop system. The reactor is equipped with an electric heating system to adjust the anaerobic tank at the desired temperature. The treated wastewater is tested for field irrigation, and preliminary results showed that plant growth was comparable to that attained when drinking water was used without any noticeable adverse effect on the plants or the soil. The integrated pilot system, combining intensive and nature-based solutions for wastewater treatment, is located in Imola. The pilot activities will be performed on an existing experimental platform recently built within an Italian national project. In this way, the platform will also be exploited for additional and specific studies related to the FIT4REUSE objectives. It can test different combinations of upflow anaerobic sludge blanket, anaerobic membrane bioreactor, molecularly imprinted polymers, single or hybrid constructed wetlands, and ultraviolet disinfection unit. These combinations will be used for treatment of real domestic wastewater with an occasional discharge of industrial effluent, and will aim to produce effluent that has a quality needed for irrigation of agricultural crops. Moreover, combining intensive and nature-based solutions is expected to reduce treatment costs, improve removal efficiencies, and make wastewater treatment process more sustainable. Upflow anaerobic sludge blanket can use organic matter to produce biogas, while constructed wetlands are low-cost technology able to further treat wastewater with low energy input. The pilot plant has a central control unit, also accessible through an online platform, allowing everyday operation and monitoring of its functions. For example, flow rates, biogas production, and other operative parameters can be constantly monitored. Two pilot systems are operated by Mekorot at the Lahat brackish water desalination reverse osmosis plant within FIT4REUSE. The Lahat plant receives water from 24 different brackish water wells and is a part of a national rehabilitation project of the Israel's coastal aquifer. The plant includes pre-treatment stage of coarse and cartridge filtration, followed by 2 stages of reverse osmosis desalination. The pre-treatment design was done with the goal to preserve the reverse osmosis membranes and to prevent or slow down deposition of colloidal, organic, and biological matter at the front of the pressure vessels. The general objective of both pilots is to improve the reverse osmosis pre-treatment in an attempt to enhance the treatment performance, thus decrease energy and chemical consumption. Both pilots are monitored online, as well as daily by field measurements and periodically by lab sampling. The first pilot, micronic cartridge filters pilot skid, is used to investigate different cartridge technologies. The pilot consists of 2 identical branches that are operated in parallel. Each branch includes a cartridge filter followed by a reverse osmosis membrane. The objective is to characterize various innovative cartridge filters in order to find the best one for the Lahat plant. The second pilot, reverse osmosis desalination pilot plant, is used to investigate the fouling reduction device technology. The pilot includes cartridge pre-treatment followed by 2 stages of reverse osmosis desalination, simulating the commercial plant. 3 fouling reduction devices are installed externally to the piping prior to the cartridge filtration or reverse osmosis stages. The fouling reduction devices transmit an electric field into the pipe and the water, with the objective to improve flocculation capability as well as prevent precipitation of salts, organic and/or inorganic material and bacteria. The desalination pilot plant is located at Isbat. It consists of an innovative desalination system combining nanofiltration and reverse osmosis. The pre-treatment module includes a 5, 10, and 20 micron cartridge filters, activated carbon column, and injection of antiscalant to remove impurities and prevent clogging. The hybrid system, nanofiltration and reverse osmosis, is expected to reduce energy requirements and improves the recovery rate of desalinated water. The brine was used to irrigate medicinal halophytes, salt-resistant plants. This will not only reduce the negative effect on the environment, but also contribute as an additional economic income to the system. Also, solar energy was considered to cover the energy needs of the desalination pilot. The amount of 30-35 kilowatts daily produced was found enough to operate the hybrid system membrane unit. FIT4REUSE simulation platform was designed to simulate simplified models of the FIT4REUSE solutions as a tool mainly for decision-making, suitable to simulate different scenarios for different cases. It enables users to perform dynamic simulations of nature-based and intensive resource recovery solutions regarding the choice of treatment options for different locations and wastewater sources around the Mediterranean region. The platform is capable of simulating single units as well as treatment trains with the innovative solutions of FIT4REUSE. It can be applied to continuously operated units with fluctuating pollutant inputs. The platform is also capable of calculating the reclaimed water quality, the energy costs and carbon emissions of each unit along the total system configuration, and therefore it is a powerful tool for possible energy savings and for preventing excessive carbon emission impacts. The RURO demonstration platform is dedicated to water reclamation and reuse for agricultural crops irrigation. The objective of the platform is to test and to validate solutions for water reuse in rural conditions, for domestic wastewater treatment plant with limited flow and load capacities. The platform is located in Saint-Jean-de-Corny, a town with a population of 1,000 people near Montpellier on the Mediterranean coast of France. Sanitary, environmental and agronomic risks related to water reuse, such as micropollutants or salinity issues, need to be quantified, managed and controlled. Also, the benefits related to water reuse need to be demonstrated and quantified on the field. In FIT4REUSE, different types of flushing methods for drippers and different storage conditions are tested before irrigation of tomatoes and salads in controlled conditions. The tests carried out focus on irrigation management, aiming at answering the questions about the benefits of water reuse in terms of fertilization, how to deal with water quality evolution in open storage, and what are the best on-field solutions to limit drippers clogging. Thanks to FIT4REUSE project, different treatment solutions are being developed and tested in the consortium countries. Application of treated non-conventional water resources for irrigation is being assessed, and relevant stakeholders are being consulted and involved in order to get the most relevant results. Also, regulatory and social aspects are being taken into careful consideration, as the applicable legislation and the public acceptance are crucial aspects of water reuse. Actions and results of FIT4REUSE will contribute to the challenge of closing the gap between water needs and water availability, one of the main issues of our times. Join our cause. Help us reuse to reduce.
Good afternoon again, welcome back. We are in the last sessions of our events, of our third Water Reuse Day of the project Fit4Reuse. And this session is devoted to a panel discussion, Water Reuse, the Italian experience. So the main goal of this session is to shift from the general point of view in the Mediterranean to an application and experience on water reuse in a territory, and in particular in this region, the Emilia-Romagna region, where we are at the moment, and in particular in the Bologna area. So here we have with me, as a panelist in this panel, we have Maurizia Brunetti. Maurizia is responsible of innovation and business development of ERA. ERA is one of the main Italian utilities, water utilities, and they manage water services in most of part of this region and also in the closer region. So I have also with me Michele Solmi. Michele is responsible of environment and irrigation activities in the irrigation consortium of Bonifica Renana. He is one of the main and the most recognized irrigation consortium in Italy, and of course they work in Bologna area as well. We have also with us Francesco Tornatore. Francesco is responsible of water services in the Emilia-Romagna region, and we have also our friend and colleague Francesco Fatone. So the idea is to discuss about the Italian case studies, the Italian experience. So I will start with Maurizia. Maurizia, ERA was for us, University of Bologna, but also Polytechnic University of Ancona, so the Italian partnership of the Fit4Reuse, one of the main stakeholders of the project, for sure the main stakeholder at the Italian level, since ERA hosted all the pilot systems you have seen in these couple of days. So we hosted the pilot system on constructed wetland within the Granarolo wastewater treatment plant managed by ERA. They hosted the integrated pilot systems in the wastewater treatment plant of Imola, and they hosted also the irrigation platform with treated wastewater in the wastewater treatment plant of Cesena. So for us, they represent really the main stakeholder, and they helped us a lot. So this means, from my point of view, Maurizia, that ERA has and demonstrates a very high-level interest in the topic of the use of non-conventional water for irrigation in agriculture, in particular the use of treated wastewater in irrigation. And also you demonstrate, from my point of view, an high interest in collaboration with the universities and research projects. I would like to ask you, from my point of view, from our point of view, it was a very good experience, a good collaboration. I would like to know, what do you think about the collaboration with us and about this project? And in general, these are pilot research experience, but you, together with the Irrigation Consortium, we will say later, already have experience on the use of treated wastewater for agriculture. So please let us know, in your opinion, this experience, and also your opinion and experience about what real water reuse in your territory. Thank you, Maurizio.
Okay. Surely the reuse of wastewater is one of the main pillars that ERA has in our industrial plan. In fact, since different years, we have started projects and collaboration with the stakeholders of our territory, and we think that it's important to apply this reuse of wastewater to use two main strategies. The first is the possibility to have a great technology and innovation in our wastewater treatment plants. And so surely the pilot projects that we had with the collaboration of the University of Bologna are three main examples of what we can do in our plants. And so in Imola Santerno, in Glanalolo, in Cesena, we have great examples of technologies that we can apply also in a large scale. But surely, as it was told before, the challenge is not only a technological one, but also not technological, because from different years we started to share our information with the other stakeholders of the territory, not only the consortium of Bonifica Renana, but other consortia that we have in our territory, the Regione Emilia-Romagna, in order to have some framework agreements, because we think that the discharge point in our wastewater treatment plant is not only the end of the integrated water cycle, but also the beginning of a second life that we can give to this effluents. And so for us it's important in these agreements to share information and to have the same objectives with the other stakeholders of the territory. For example, with the consortium of Bonifica Renana, since 2019 we subscribed these agreements, and this has surely been a good example of what we can do and how we can share also the different opinions and give value to our volumes, not only in the direct use but also in the indirect reuse, because this is the focus of the collaboration we subscribed in 2019 with the consortium of Bonifica Renana. So I think that perhaps Michele can add other information about these agreements that we subscribed from some years ago.
Thank you, Maurizia. Yes, Michele, so we understood that you already are working with treated wastewater in some of your irrigation districts. I have to say that the irrigation consortium of Bonifica Renana was one of the first irrigation consortium that achieved this goal and decided to go in this direction. It was not an easy process. Some concerns have been in the past, but now but I asked Michele for sure about this, they seems that they fully agree with the direction to follow. So the treated wastewater are a valuable resource for the irrigation and for your purpose. So, Michele, tell us something about your experience on these aspects.
Yes, as Maurizia said, in 2019 we started this experimental agreement for the reuse of treated water of Eder, which is the main treating plant in Bologna province. So the long story short, we withdraw the water from the treatment plant and we put in our network, and we used for agricultural purposes with a high level of success. But this was, as Attilio told us, something that happened before all the drought and all the rain crisis that we had this year. So now it's even more clear that treated water is one of the most important sources of water in our region, because here we are on the wrong side of the Po River. We don't have Alps, we only have Apennines. So the water and the rains are very, very scarce during the summertime. So the only water that comes for sure during all the summer and also during the winter is the treated water. So we started using EIDER, which is, as I told you, the main treatment plants of our region, of our province. But we also we have been using more than 30 treatment plants, minor treatment plants, in all our network in the last 20 years. So we have been using this kind of water for a very long time. So we have quite a big expertise about this kind of water. As I told you, because in our region we don't have a lot of water. We are in the north part of Italy, but the rain season is only during the winter when we don't need it. For example, in seven treating plants are the main water source of 7 irrigation districts. So especially in the western part of Bologna province, we couldn't have any kind of irrigation without wasted water. So for us, it's a very, very important. Moreover, it's so important for us that we invested with also public financing, a lot of effort in trying to stock this water. And next year we will start to use a reservoir. We built a reservoir after one of ERA's treating plants, and we stock more than 100,000 cubic meters of water during the winter to use during the summertime. So for us it's very important not only to use during the summer this water, but also to stock it during the winter. So it's very important, not only for a quantity point of view, but we are working with ERA to assure also a very high quality standard, because this water is used for edible purposes, because we produce vegetables, we produce crops that are used in everyday market.
Thank you, Michele. And I would like to add that all this case study, real case study, were possible because you did an agreement, but under the umbrella of the Emilia-Romagna region. So even in this case, this region was one of the first in Italy to apply such agreement within a previous Italian law directive. It was not so easy, but this region was able, since a lot of years, to believe in the wastewater reuse approach, and started with several case-by-case agreements between water utilities and water users in agriculture, and so irrigation consortia. So Francesco, this is for sure a key point that made this possible. But now we are under a new European regulation, and we are going to the full application in Italy of this new regulation. So, from your point of view, how was your experience with this real case study that are working in the Emilia-Romagna region, and which is your feeling about the new perspective? Thank you.
Well, as they said before, the reuse of wastewater in our region is necessary. We cannot do without it at this moment. In the last 20 years, we have had a significant decrease of rainfall. We have estimated this decrease in about 12%. So, according to the standard precipitation index in our region, we go from moderate drought to severe drought. So it's very important for us to find alternative resource of water. It's obviously that the sector that is most affected by the climate change in our region is the agricultural sector. This doesn't mean that our system is efficient, but is extremely fragile. So it's clear that in such context we need to find alternative to improve the availability of resource. And so that's why in this period we are looking for a mix of solutions that can allow us to find this resource. And wastewater treatment and treated wastewater are very important in this context. So that's why we have tried to use a different approach to the issue of wastewater reuse in agricultural, because our legislation is too much restrictive. And so we need to find alternative way to can implement the reuse in our region. And the experience of IDAR or the experience of Mancasale are very important for us in the sector, because they give us the possibility to introduce in our system a different way to approach to the problem of reuse, which is very similar to the risk management plan of the new European legislation, which is not based on the effluent standard only as our regulation at this moment, but is based on the risk management, which is a very different approach from the effluent standard. The risk management is more feasible instead of the effluent standard. So it's very important for us, this experience, and to replicate this experience at the regional level.
Thank you, Francesco. So, to summarize your words and the other words of the colleagues, I think that due to climate change, we need to increase the resilience of the system, of the distribution system. And talking about this, increase the resilience means to exploit all the possible alternatives as adaptation measures, as mitigation measures. And in this sense, we estimate that the use of treated wastewater in context where, for example, the storage of water in big reservoirs are not present, like in this region, is very, very important, because this year, probably all of you know this, the drought of this year, the water crisis of this year, occurred mostly in the northern part of Italy instead of the southern part of Italy. This is a kind of novelty. Usually, the southern Italy was more affected by drought, but this year, honestly, also in the past recent years, the Italy was in the opposite sense in terms of drought. So they increase the awareness and the ideas to store more water and to use alternative resources. Of course, the wastewater reuse was limited in the past due to Italian legislation, as Francesco said, and also to some concern about the cost of the treatment and who pays for additional treatment, who pays for the distribution of water. In this sense, from my point of view, and now I ask to Francesco Fatone, the new umbrella of the new European regulation should help us to increase the use of treated wastewater in agriculture. But also maybe, Francesco, as you said several times, the new proposal for the regulation of urban treatment water. So, Francesco, tell us your opinion and a little bit more about the European framework.
Yeah, thank you. Well, I'm following what Simos said in the previous panel. The 26th of October, the proposal was published. It's still a proposal, so there will be discussion in the Parliament and Council. But this proposal of the revision of the Urban Wastewater Treatment Directive is very ambitious. And actually is providing targets about micropollutants removal, is providing targets about energy neutrality, carbon footprinting, and also about nutrients. So the gap that was so far about treatment towards water use and treatments towards discharge is going to be reduced more and more. Because, for example, if you want to achieve the class B or class C, probably you will need less technologies than plants that will discharge in sensitive area. So that's a kind of revolution. So most probably now the real challenge will be not the cost, but the governance. Because at the moment, still, well, the agreement is very much related to the current situation. Well, we had water scarcity, and during water scarcity, a lot of reuse was actually put in place. And then maybe this will be in place also next year, because we had it the first time. The current regulation on water use and also the national decrees will have a crucial role in facilitating governance. And anyway, the couple of Urban Water Treatment Directive and the new regulation together will bring an upgrade of treatment plants that, when necessary, will discharge, because we have to think also about treatment plants that are feeding rivers that are dry. So in many cases, rivers will need that water for the ecosystemic value. And in other cases, in the irrigation season, this water can go to, to water use for agriculture. So this new versatility, flexibility of the treatment plants is probably facilitated by the new directive. Even this is still a proposal, so we will hear about the water utility perspective about this new approach.
Yes, for sure is a new paradigm that could help the water reuse, but also could lead towards increasing in the treatment capacity of our plants. Not so easy, but for sure the direction is that one. So I think that the new regulation from Europe is leading the Italian government towards a new directive, a new legislation on water reuse. This is not yet issued, but they are working on it, but some drafts already circulate, and I think that some good ideas, key points are arising. And I would like to highlight two of these. One of these is that the reuse, the real reuse at a larger scale needs, for sure, a correct planning activity at the beginning. The second is what Francesco Tornasole said before, that according to the European regulation, the paradigm changed. So no the threshold limit for the effluents, but a risk assessment approach. So I'm very happy to say that also due to the results of FIT4REUSE, you know that we worked in the development of a methodology for the risk assessment plan, Francesco told us before. And thanks to the other consideration and reflection coming from our research activities, in this region and in this territory, in the Bologna area, ERA and the Bonifica Renana Irrigation Consortium decided to go ahead, and they want to apply what we developed within also FIT4REUSE approach. And we are discussing, and I believe that we will start early next year in January with a new study with the University of Bologna and Polytechnic University of Ancona that has two main objectives: planning the reuse, that means the real potential, the reuse in all the wastewater treatment systems managed by ERA that are located within the irrigation districts of the Irrigation Consortium of Bonifica Renana. And also, they asked us to apply the methodology to develop a risk management plan in one of the districts where Michele said us that the treated wastewater are the principal resource, water resource for irrigation. So me and Francesco have to say thanks to this very relevant stakeholder for this, and I think, Marco, that is a real application, and we had some impact, it seems, so in the real life. And so I ask Maurizia and then Michele the same question, and then Francesco. How is your perspective? You want to go further in this direction, and you said that you have also the reuse in the business plan of your company. Tell us more why, and you asked us to do this. Thank you.
Well, surely the pilot projects we have done in last years have given us the opportunity to evaluate projects in a large scale, and so the possibility to have projects in a full scale for our treatment plants. I think that it is important that we have an holistic approach, both in the district that we evaluate, in the new agreement that we will subscribe with Consortium of Bonifica Renana and University of Bologna. We will evaluate the risk assessment in the district of Bologna. And surely it is important to have the mapping of all the characteristics of our plants, especially in the tertiary sectors. But also it is important to have a risk assessment in all the integrated water cycle. So perhaps in last years we have considered the integrated water cycle as the supply chain, which is managed by the utilities such as ERA. But now we have to convert a new paradigm in which we must consider not only the integrated water cycle, but a new hydrological district in which there is not only the network and the plants which are managed by HERA, but also what there is after our discharge point. So I think that the key word is the holistic approach and risk assessment in both the phases of all the integrated water cycle, and not only until the discharge point. The second aspect is that surely we have developed, with the collaboration of the University of Bologna and the region of Emilia-Romagna, the water safety plan in the supply chain of the drinking water. And so this can be a paradigm that we can transfer also to the wastewater, and so I think that we can have an advantage under this point, because the model is similar. So we have to change the paradigm, but surely what we have done with the drinking water can be an example of this new approach.
For sure, for sure. Michele, so it means that also from your point of view, have a planning, a clear planning of the possibility to exploit this valuable resource could help also maybe in the investments you have to do to improve your networks of channels, of distribution network. I ask you, I have a curiosity. Your farmers, the farmers you supply with water, are in agreement with you with the use of this non-conventional resource? Which is your experience now, and what they think about your planning to increase this activity?
We are very transparent with our farmers, and they know the source of the water that they use, especially in that 7 districts where the treated water are the main source. So they agree with the use, and they're perfectly happy when we proposed to create basins to save even more water. So our experience in the last more than 10 years of using of wasting water of treated water as a source, as an important source, is absolutely positive, and we have never had any kind of problems with their production, and farmers are very used to phone us for every single problem. So if they didn't phone us 100 times a day, that means that everything worked fine. Moreover, with the University of Bologna, we are having other measurement of the quality of the water, not because we don't trust, obviously, ERA, and we don't trust ARPA, but we want to have even more measurement to give more information to the farmer, and we are also measuring not only the water, but the final product, the apple, the tomato, the salad, to know all the circle, to be completely sure of what we are giving them, because they are not having ERA as the first actor. They are having Bonifica Renana who give them water. So we want to be sure of the quality of water that we are giving. And I fully agree to Maurizia when she said that we have to use an integrated scheme, because in the past they cared till the end of their plant, and we cared from the canal till the farmer. Now we have to work together, because what they do have, and now we perfectly know, and we all agree of that, we have a very important aspect even till the production of vegetables and to the farmers. So now we have to work together, and to know, they have to know what we need, and obviously we have to know what they can give us. So we have to work together with this kind of risk assessment, with this kind of master plan, to know in the reality which are the possibilities for all our territory. Because with the climate change, we think that this is the best investment in stocking this kind of water. But we cannot do without the university, we cannot do without the region, and we cannot do without ERA. We have all to work together to obtain, in the end, one final result, having more water, more quality water for the general use, and avoid the withdrawal of water from the underground, obviously, to use for agricultural purposes, because this have to avoid. So working together is the real key word, in my opinion, of this that use.
Thank you, Michele. I could say that is real and added value, and the thing that something is changing about the use of non-conventional water. Francesco, from the regional point of view, how is important the right planning in advance at larger scale? So to go through a real assessment at larger scale, and not to use single agreements on single case study, not only at the regional level, but probably it could be done also at basin level. Which is your opinion about this?
Well, actually, we are recovering about 20 millions of wastewater in our region, and we have estimated that we can recover about 100 million of cubic meters of water per year. So we are far from our goal. Until now, our approach has been limited to conducting experience plan by plan. So it's clear that for us it's very, very important to have an approach to a large scale, because it's much more interesting for us to know how many resources we can allow from wastewater, so we can allocate with more target the few resources that we have, the few natural resources that we have. So for a basin balance, it's very, very important for us this kind of approach. That's why we are we see with very interest to the experience that consortium of Renana and ERA are doing with your support, because can give us a new instrument to make our planification about the water resource. And that's why we want to propose to include this experience in an agreement, in a large agreement made also with Po River District Authority, because it's very important to have this kind of instruments for our planification planning. So,
thank you, Francesco. Francesco Fatone. So, going back to the risk assessment plan, for sure you told us before that one of the key points is also the monitoring of the entire chain from the basin, you said, till the fields. What do you think, what do you imagine for the monitoring from the point of compliance, so the effluent, till the field? What do you think? Like a suggestion, of course, this will be a result of the risk assessment plan. But in your opinion and according to your experience, the monitoring system, because it's very important for you, that the irrigation consortia has to implement in your network, which point of attention has to tackle?
Thank you very much. Well, as Maurizio mentioned, the approach is very similar to the water safety plan in terms of schematization. So we will schematize the system into nodes, and this will depend also on the use of water and typical crops that are grown, because this will differently interface with the water quality. Nowadays, there is an increasing quantity of data that are coming both from water infrastructure that TERA is managing and from the irrigation infrastructure that Consortio Renana is managing. And this flow of data is not harmonized. So I think that the first step should be the harmonization of this data that are already available and see what information we can already get now by validation with targeted analysis. So the first phase, maybe the first 2 years, is a validation of indirect parameters that usually are cheaper. We cannot pretend to analyze all the list of micropollutants once a week or whatever. So let's see, site by site, how we can get indirect information from the digital data already available, and what we have to analyze because we don't have information. And once we have this catchment by catchment information, we can set a monitoring plan that is seasonal, is of course more intense in the irrigation period, less intense when we don't have irrigation period, but we have to think about storage. So there will be anyway some monitoring, not the same all over the year. But I think we're talking about Emilia-Romagna. I think we met already when we were talking about sludge management. Tracking and tracing is crucial. And if we think about the approach that has been applied for a sludge application that is much more complex from some point of view, can give some take-home messages. So this tracking and tracing, this platform on data that is taken from the field, is communicated to the region, and the region is merging this information, is a good inspiration also for water use. I think water use is less complex because the interaction probably is less complex when you consider water compared to sludge. But, well, these bases are already there from the methodological point of view, from the past experience, and also from the valorization of data.
Thank you, Francesco. We are going to finish our session. I think that some ideas we are working on with Francesco, but with the other partners of the consortium, say that probably this region could become soon a large demo site or living labs, as now is usual to say, related to the integrated use of water. Since here we have, as you can say, an agreement, a road to follow, where all the actors, all the stakeholders, starting from the political level, the region, the main actors, that means who actually currently manage water for potable use, but also for irrigational use. And researchers want to work not only at pilot scale. Of course, we started from the research. We applied some test and research activity on treatment, application, development of assessment tool, but we would like to develop some collaborations that make together several actors to really demonstrate that Italy, this region, this area, are able to be the Italian living labs for wastewater reuse application under the new umbrella of the EU regulation, but also following the new Italian legislation about this. This is my opinion, and also my what I hope. And in 30 seconds, what do you think about this? Could be a good idea? Francesco, starting from you.
I thought it was Maurizio, so yeah.
No, Francesco.
Let's start with science. Of course, I think, well, we have all those stakeholders here that already expressed their wish to, they are already collaborating. This is a very good starting point. So there is a past experience that has paved the way for this living lab. I think the role of the region is crucial because there is a need of governmental coordination that is setting the scene, but also is monitoring that the methodology is implemented well, not only when we have water scarcity. When we have water scarcity, we are in the newspapers, in the magazine, and it is a high level of attention. When we have rain, so the attention
go down.
Yeah, the lower the region has to have a coordination role and monitoring role to make sure that this water is valorized anyway in all the periods of the year. So I'm very positive about it. And well, but now let's listen to Maurizio probably.
Yeah, Maurizio.
I think this is surely the great roadmap, and the collaboration and agreements that we are going to subscribe is important to achieve the results and also the objectives that all the different stakeholders have in their master plan. So one objective and different actors and sharing data, sharing informations are obviously the base to achieve this objective. So I think this agreement will be what we are going to do.
The first step to go on. Maybe we miss one other very important key actors that are the farmers. But I remember that in Italy, irrigation consortia.
I can speak as an end user,
yes,
as
exactly.
not a representative, obviously, of the farmers, but I know that they are ready from a psychological point of view. Consortium are ready because we have a lot of data on what they need and the quality of water we draw in the last years. So I think that we need it now. We are ready, and we need a general supervision on that master plan. But I think we are really, this is the moment. And the drought of this year helped us in this readiness.
The drought pushed us, but Francesco, what do you think about this? This region is ready to become a living lab on wastewater use, and also the Po Basin, maybe?
Yes, of course. I think, yes, it's obviously, we are working since 2015 to 2016 with this approach. So I think that until our rule, without our rule, maybe consortium and ERA, maybe it's the first time that they operate together with this kind of approach. And in this way to work, it's very important, I think, our role. So it's evident that Emilia-Romagna region is now ready for this role, and we want to go on this way.
A possible idea for the next project is to create the same approach and the same collaboration in several countries in the Mediterranean, but we will see. Thank you so much. Thank you, Francesco. Thank you, Maurizio. Thank you, Michele. Thank you, Francesco, again. So please, could you leave the stage? I believe this is another key point we achieved within this third Water Reuse Day. And now I call to the stage Marco Orlando again. Marco, please. We are going to the final step of this event. Now we have Marco, our project officer, that tell us about the general PRIMA program and its support to the field of sustainable water management. This is also an auspicious for the future. Water management is important, you said several times. You heard a lot of things in this couple of days. So Marco, the floor is yours. Thank you.
Thank you, Attilio, for reserving a spot for me, since we're going towards the closure of this very interesting event. And let me congratulate as well you for giving us a bit of an essay of what we expect from projects. Of course, we love to see our scientists interact with stakeholders, so that, of course, you can find ways to bring project results to end users, and to guarantee that we can implement water reuse, possibly in the future on a wider scale. Okay, so I know that everyone is tired. I will try to contain myself and finalize the presentation within the agreed timeline, 20 minutes. Of course, I will not introduce myself, because by now you should know me already, but I hope for the people from home who maybe are not very familiar with PRIMA, this will be an occasion to familiarize a bit with the program and the main aspects of the program. Right. So I'll skip this, I'll delve right into the contents of the presentation. Just a few details on we could say the PRIMA history, how the program was born. Of course, we know very well that this is a research and innovation funding program. That is, we could say it's a challenge-based program that, of course, aims at tackling the most pressing, shared, common challenges that the Mediterranean countries are facing, like climate change. I mean, we discussed extensively about these issues here. The steady growth of population, especially in the south, and related food security issues, water scarcity and the overexploitation of natural resources, the unsustainability. We spoke about sustainability of water management, agriculture in the Mediterranean. Of course, this is a very important theme, which these unsustainable practices many times result in a loss of agrobiodiversity. Mediterranean is very rich in terms of agrobiodiversity, but of course we have to be mindful of the consequences of not implementing sustainable practices in the Mediterranean, what happens in these cases. And of course, to stimulate, to kind of increase the capacities in terms of innovation, to bridge the gap in the agro-food value chains. Now, these are huge challenges that, of course, PRIMA alone will not manage to solve. However, there was a long discussion for several years on how to have an instrument that could have sufficient, we could say, that could be of the sufficient size or magnitude to be effective in tackling such challenges that, of course, required a huge contribution from many sectors. However, the way PRIMA works is I mean, we are focused on these three main objectives that I'm sharing here. First off, the alignment of national research and innovation programs, because what was necessary when we launched the program was that we kind of harmonized the priorities chosen in the different national R&I programs, so that we could bring together researchers and we could make them work towards solving the same issues without having scattered projects around the region. So it was necessary to have all the national funding agencies, all the ministries, all the agencies for the promotion of science which are involved in the program come together to define shared priorities. Of course, a critical mass of actors and resources is what we need to have an impact at scale by bringing together public and private sector. We just saw, until now we have seen that this interaction is very needed, and of course by pooling knowledge and financial resources, by creating this critical mass, strengthening research and innovation capacities in the region, of course, and also increase the capabilities to implement efficiently research and innovation in the Mediterranean, again, by building on this critical mass of resources and actors. For those who are not familiar with the EU jargon, what we mean by Article 185 of the TFEU, the Treaty on the Functioning of the European Union, this is, let's say, the legal framework within which the program operates. Basically, the main characteristics of this legal framework are that the partnership is built on the so-called equal footing principle. Okay, all the countries involved, EU and Mediterranean partner countries from the southern and eastern shores of the Mediterranean, participate in the program as co-managers, co-owners, and this is basically the real meaning of the equal footing principle. It's an initiative which has a long-term commitment, 10-year long, but we are working already for a continuation of the program. Again, based on what I said in the previous slide, of course, you may understand that one of the important things that we want to achieve is to avoid duplication of research and innovation projects and efforts. We want instead to work on the contrary, we want to bring people together so that they can work together on the same issues to be more efficient. This program is based on implementation of the so-called SRIA or SRIA, Strategic Research and Innovation Agenda. I'll go to that in a minute, and I suggest that everyone who doesn't know very well PRIMA reads this document, which is available on the website. And again, on developing institutional relationships with the Mediterranean stakeholders from all the sectors. I will not spend a lot of time here, but you can see that the inception of PRIMA dates back to 2012. That is when the idea of a Mediterranean research funding program was born. However, it took some time and several years of political and technical negotiations to, of course, come up with a strategic research and innovation agenda, have the endorsement of all the stakeholders, including the European Commission, the European Union, and all the ministries involved from different countries, until 2017, when the strategic research and innovation agenda was basically approved, and the PRIMA Foundation was the body responsible for the implementation of the program was set up, and the first calls were launched in 2018. Very important slide for those who are wondering where you can find partners from your projects. Of course, these are the countries involved. From each and every country, we have a specific agency or ministry that represents that country, injects funding in the program. We have 11 member states from the European Union and 8 countries from what we call the Mediterranean partner countries, which also include 3 associated countries, as you can see on the PRIMA map. Now, about the vision and mission, again, it's very much in line with the topics that we've been discussing until now. What we want to work on a more efficient management of natural resources, have a more efficient, more sustainable water management and farming systems, valorize also the great potential that we have in the Mediterranean agro-food value chain, and of course, generate an impact also. I mean, it's very difficult, but we want to contribute also to generating an impact at economic, social and political level in the region. Something about the governance. The Board of Trustees is basically the governing board where the representatives of all the countries sit. And as observers, we have as well the European Commission and the Union for the Mediterranean, who are very important partners for us. Of course, we receive scientific advice from the Scientific Advisory Committee that helps out with the identification of the main priority for the for the annual work plans and the related calls for proposals. The PRIMA Secretariat is the operational arm of the foundation, where I work basically, which has its seat in Barcelona. And just to remind you also of the financial contribution of both the participating states and the European Union, of course, this also required a lot of political discussion, but I mean, it was agreed to that the PRIMA initiative will count on a budget of around 500 million euros for the implementation of calls. And I mean, I already told you that the time frame will be about 10 years. This is important. Please, for those who are not maybe familiar with all the main pillars of the Strategic Research and Innovation Agenda, this is available on the PRIMA website. It's this document that sets the technical core of the program, identifies for each thematic area the main pillars, the main, we could say, general topics around which the program is built. It was a document that was the result of a series of workshops, seminars, meetings with stakeholders. We brought together over a couple of years in many encounters scientists, farmers, policymakers, and so on. And of course, all the contributions ended up into the Strategic Research and Innovation Agenda. So it's good for you to be all familiar with the different aspects identified in the Strategic Research and Innovation Agenda. Thematic area, PRIMA is built around, we could say, 4 thematic pillars. So sustainable management of water, sustainable farming systems, and the agro-food value chains. Of course, we cannot forget the so-called WEFE nexus, the water, energy, food, and ecosystem networks, nexus, that looks at the interdependencies, the trade-offs, and interlinkages across the 3 areas. And we're increasingly focused on also on the, we are also with the calls for proposals that we are launching, we want to go beyond this silo mentality and bring people together so that we can mainstream across the Mediterranean the nexus concept. Very quickly, for the thematic areas, I would just like to show you what the main priorities identified for each and every thematic pillar are. So of course, for water, we have water resources availability and quality within catchments and aquifers, sustainable integrated water management, irrigation technologies and practices, and the use of alternative water resources. Of course, when we launch calls for proposals, normally 1 or 2 of these, let's say, priorities tend to be more apparent, predominant in the calls for proposals. So, I mean, this is what you can expect even for next year, that some of these aspects will pop up in the next annual work plan. To a certain extent, we know that there are overlaps, so I mean, it's normal that one call is not entirely focused on one aspect. And of course, when in 2018 for Section 1, we launched a call about the alternative water resources, and within the margins of this call, FIT4REUSE and the other 2 projects were selected. Farming, the priorities are the following one. The 3 identifies as main priorities: the adaptation of agriculture to climate change, of course, a theme that we have debated today and yesterday as well, developing sustainable and productive agro-ecosystems, the prevention of the emergence of animal and plant diseases, and the development of farming systems that are able to generate income, create employment, and contribute to a balanced territorial development. Of course, these are wider topics that when we launch calls for proposals, of course, we narrow down a bit the scope, but this is to give you the idea of what you will see even next year in the next calls. And by the way, before Christmas, we should, communicate what is going to be the call calendar for next year. So for those interested, you will have to wait until next year, but we may share some news in December. We go to food, the agri-food value chain, so the valorization of the traditional med diet, of course. Another important theme, food safety in local food chains. The implementation of innovation in the agri-food value chain, okay? And another important, interesting theme, the implications of dietary shifts and sustainable diets for the med population and food industry. Now, what we care about is also generating an impact at the social, economic level, apart from having an environmental impact. So, of course, you can see here some examples that we like to see. We stress these aspects also in the, when we launch a call for proposal, but of course, this is what we like to see into our proposals, that you know, they justify how they are going to achieve different types of impacts at different levels. And of course, what we like to see in the proposals is a justification as to how your project will also contribute to, of course, partially the achievement of any of the relevant SDGs that are relevant for your project. Something about the structure. Don't get too scared about this slide. It's just to make you aware of the fact that PRIMA works, basically it's divided into two sections, section 1 and section 2. The way the submission of the proposal works is the same. The PRIMA IES, that stands for PRIMA Implementation Structure, basically the PRIMA Secretariat, where I work. It's the body responsible for the management of the whole process, from call publication to project selection, monitoring of the selected projects, and so on. The only difference between these two sections that you have to understand is that for section 1, the funding comes directly from Horizon 2020, and the grants are signed between the consortium, the beneficiaries, and the PRIMA Secretariat. For section 2, there may be, of course, there is a difference because the funding comes from the ministries, the national funding agencies involved in PRIMA. So for the grant signature, the matter is basically between the funding agency and the beneficiary. And in terms of eligibility, there may be some, let's say, different rules based on the national legislation of the specific country for section 2. We mentioned these acronyms, RIA, IA, RIA, IA. Of course, it's good to know that we, of course, wish in the future to focus more on innovation, but there are different types of actions, projects that we finance, namely research and innovation actions that, of course, are focused more on the generation of new knowledge, okay, that can help maybe for the development of technology, while, for example, innovation action, they are more unbalanced, they're more oriented towards the application, the market uptake, and so on. So they focus on activities like that are prior to commercialization, like prototyping, testing, piloting, and of course, what we wish to have is actions that are more prone in the future to, more oriented towards the market, more oriented to scaling up. But of course, we will be launching both types of call in the future, and CSAs, which are more unusual. These are projects that normally are providing funding to support cooperation, coordination across researchers, different types of institutions, or exchange actions. And you can see also the different requirements in terms of TRL and the funding rate for each type of action. Here, I don't think I have to explain what the TRLs are, and I start seeing people are very tired, so I think I have to close soon this presentation. Just some number to show what has been achieved until now by PRIMA. Again, it's a very young program. As I like to define it, it's a big, small program because, of course, in a few years, we managed to fund a big number of actions, a big number of projects. We brought together many researchers and many stakeholders around the Mediterranean from the different countries. You can see here, until now, 168 projects funded with more than 200 million of euros invested from both the European Union funding and the national funding. More than 1,500 beneficiaries from all the Mediterranean involved in the projects. Actually, you can see that here there is a QR code. If you scan it, you will be redirected to the PRIMA website, where you will see that there's a so-called analytical tool which gives you access to all this information about beneficiaries, funding, and so on. It's very interesting, and it shows where the projects are being implemented in the participating states. Of course, success rate is a bit low, as you can see, but it's because the program is very competitive, and well, hopefully we are also selecting the best proposals. So again, here the numbers that I show again, just I will not repeat too much things, but you can see that both Section 1 and Section 2 are really the building blocks of the program, and are providing an opportunity to beneficiaries from all the Mediterranean to further do research. So again, the numbers are quite significant, I think. Here, just for those who wish to know what most of the projects are focused on, we can see that farming systems normally is the topic that receives more applications, and normally where we have funded more projects, but of course we have a good number of water projects, and also addressing the agri-food value chains. Increasingly, we are giving space to the nexus, and this is something that is becoming of growing importance for us. We want also to associate PRIMA to the implementation of the nexus in the Mediterranean. So hopefully we will have more projects on this. And well, here, just statistics to show that almost all the countries have a very good representation in terms of, we could say, a portfolio of projects, and this makes us very proud, because we think that we are contributing to the establishment of a really Mediterranean research community that can help, address the challenges that I mentioned when I started the presentation. Just some to whet your appetite a bit, because I know that many people who are now looking at the screen will recognize themselves into, these are some outputs from some projects that reached already the midterm stage, or that are going towards their conclusion. And of course, some of you are probably working on the same type of solutions, so they will be kind of interested in applying in the future. But you can see until now, we have some tangible outputs from PRIMA projects that help develop cost-effective technologies for wastewater treatment and desalination. We had some proofs between yesterday and today. Also, the other projects from the same call are finishing now, and they, let's say, they gave birth to very interesting, innovative solutions. Smart technologies for saving water in irrigation. We've had many stakeholders talking about irrigations and the constraints that it faces, so it's good to be working on this topic and develop innovative solutions. Of course, water governance is an important theme. Many projects are working on developing platforms, decision support systems, and other solutions that can help the decision-making process at a time where there are many conflicts among sectors. So this is another interesting topic. We have relevant outputs so far. Solution saving water inputs, water, energy, fertilizers, pesticides in intensive and conventional farming systems, solutions for adaptation and mitigation to climate change of farming systems, integrated management of water, energy, food, land. This is very interesting because this is your one-stop shop for getting information on the program. The PRIMA website, of course, you will find we developed several guidelines. There are several sections of the website which provide you with all the information on how the the program works. You will find the template for the applications, frequently asked questions that are very good for you to have immediate access to the information, and for me, so I save time and I don't have to answer everyone's emails. You have also the national contact point list, very important if you plan to contact your national funding agency, someone from the ministry responsible for science and innovation in your country, you find the list of contacts. Two very important functionalities. We created one section which is called Find Partners. So if you're looking for partners to build your consortium, you can post partnership requests there. You can read partnership requests which have been posted by someone else who is looking for partners, so it's good. We have several people who shared their experience and said that it was useful to build a consortium. They found partners from PRIMA projects or for other applications. And of course, if you're interested in forming part of the PRIMA expert database, because of course, we select projects, and to select projects, we need experts to evaluate applications. If you are project officers, all the contacts can be found on the website. Thank you.
So we arrived at the final stage of our event. I hope you enjoyed this third Water Use Day. I would like that Stevo, that is the core of the coordination team of University of Bologna, try some conclusion. Please, Stevo.
So thank you. We just wanted to give a short overview of these 2 days that we have been together. If we can have the presentation. Yes, thank you. So just to quote Marco, if I can, he said that PRIMA is a big, small program. I think FIT4REUSE is a big, small project, actually, because I really feel that we did a lot of things. We managed to close the circle somehow, but we were 9 partners and a limited budget, so I think we can be really proud of what we have achieved. So just a short reminder, basically the first day what we did was to talk about the treatment solutions. So we saw what solutions we have developed, what solutions we have tested and optimized for the treatment of non-commercial water resources. We talked about nature-based solutions, about intensive solutions for wastewater treatment. We talked about the desalination process. We talked about simulation platform that we have developed in order to model all these results and to have a better overview of their performance. Next slide, please. In the
activity, travel, visit, pilot system, friendships, collaboration, knowing new experience, new persons. So I believe that we did the best we can. But I'm very proud about this. So thank you very much and see you soon.